included within the session itself. Okay, fine. So let me start the session first. So can you see my screen?
Yes, ma'am.
Okay. So I'm just offing my video actually. Otherwise, it may happen that the internet gets slow. So let's start. So as I said that, so this is my contact email ID, and this is my home page, as you can see in the first slide. So in case you have, we'll obviously get a lot of time for discussions also, because we have another session. So, but still, if you have any doubts after the sessions, you can directly email me. Or if you have any doubts related to the publications that we have done, and you have to do you want to extend it in your work, then you can see the publications and the projects that we are doing in the given website. Now I'm starting with very briefly with the basics of AI and ML, and then we'll come for the what other progress has been done in the domain of human day-to-day activities, and where the research can be lied. Okay. So what is AI basically? So we know that we use smartphones. So in smartphones, we have a lot of softwares, lot of apps, right? So all these apps, they use some day-to-day AI things over there. And AI means artificial intelligence. So basically, artificial intelligence can be said as a transformative technology that is reshaping how humans interact with the world. That means it is an intelligence that is artificial, which is incorporated through some method. So in smartphones, we can see that we use if you forget about smartphones, if you are using Gmail, you can see you are using Facebook and Gmail. And if you're scrolling something, or maybe you're scrolling something in Amazon continuously, you can see in Gmail or Facebook, you will get the ad of that, right? That if you're trying to buy something and you didn't buy it, you're just trying to buy and you're scrolling on it for maybe for 1 or 2 days. After that, you will see there are a lot of ads has come in your Gmail as well as in your Facebook. So how it happens? So basically, the data that you are actually accessing in other platforms, that are basically sent to the servers, and that from that data they are giving it to the clients or to the business holders, so that they will give you ads, and from the ad they are generating the revenues. So this is another one type of AI, artificial intelligence. So they are using your pattern of searching the data for getting some information out of it, and they are just showing you some results out of that. So that is also kind of artificial intelligence. Now again, artificial intelligence have a lot of other things. I'm just saying one example of it. Now in this image, you can see that someone is doing some exercise or yoga. Okay. Nowadays, it's become very popular things to do yoga, right? So, but how the posture corrections? How every yoga instructor, everywhere the yoga instructor is there. Now, so day-to-day activities can be the activities like detection, some automated detection of the posture correction for yoga. Maybe some other things. I will come to a lot more examples. So based on this image, I'm just giving you an example. So there is an automated device which actually capturing when you are doing the yoga, it is capturing the image of your yoga posture and saying you are doing correctly or not. This is very common. It is not a big deal nowadays. Okay, so this is also an AI, right? Artificial intelligence, that is without the actual instructor, but without the instructor, he is saying that whether you're doing correctly or not. So mention it pervasiveness in everyday life, from powering recommendation systems to optimizing logistics. So recommendation system is they are giving ads to you, that is the recommendation system. Then optimizing logistics. Let's say you are using Google Map and you want the shortest path to go one place to another place. So it is actually optimizing the path, right? It is showing the maybe 3 paths and then also showing the current flow current traffic flow and saying the optimized path based on the time, based on the distance. So these are the places. These are very, I'm saying very small example. AI nowadays, it's like you cannot think anything without AI. Everywhere is there. And until you go for a calculator which is used maybe 20 or 30 years back, everything nowadays, even the calculators nowadays are also come with the AI facilities. Now, quickly about the definitions. AI is the simulation of human intelligence by machines to perform tasks that typically require human cognition. So learning from the data, so like predictions, which are saying, so or as I said, given the example for that you are searching something in Amazon. So you are actually doing some activity, and your activity, that data has been picked up by some cookies and something, and they are using that data. So learning from the data that you produce by searching, from that data they are doing the things. Reasoning, now deciding the best route of the map, this, as I said, that is some reasoning. Okay, you need they will Google Map, most of the Google Map nowadays give options that distance based as well as time based. And not only that, I think if you have observed that if there are busy regions, they will show these are the busy regions. If you want to cross this, it will take huge lot of time. Even they cannot able to calculate it. So these are the decisions taken at that time based on the reasoning. Okay, these are the parameters can be happen, and just not one parameter or just not one static parameter. Rather, multiple static parameters is also not there. They also take the parameters which are dynamic. Last is problem solving. That is prediction. We are predicting something. That okay, so if this is this is the possibilities of what are the values will be there. So predicting the values. So problem solving. So that is the last thing. So 3 things we should done. First is reasoning. First is learning from the data. Next is we make some reasoning, and finally we'll solve the problem and get some output. Without output, no algorithm, no model is actually successful. So obviously there should be some output. So problem solving is the last step. Finally, based on the data, based on the logical reasoning we have given, we have actually solved the problem. Now key elements are, so obviously data. Without data we cannot do anything. So we need data. Next is algorithms. That algorithm that we have developed for them. They may be specific, they may be generic, they may be hierarchical. That are different cases, but there should be some algorithms. It cannot be random, it cannot be arbitrary, it cannot be intuitive. Earlier days when AI has come, I will come in the next slide. There mainly the algorithms are intuitive. They are used intuitive methods. They are not algorithms. But now we use algorithms which have definite outputs. Okay. Now last point is computing power. If you think those who have been long time in this system, they knows that even 20 years back also there is machine learning algorithms are there, like k-means algorithms, genetic algorithms, all these algorithms are there, but they are not widely used, nor no one talk about them much also. Why it was like that? Because the computing power was not supporting them. That time the processors, the data storage, these are very costly. So no one actually think of doing some machine learning or forget about deep learning algorithms. Okay. So but nowadays, in last 10-15 years especially, the processing power as well as data storage has become hugely progressed. So as a result, not only AI, ML, and now DL, and then reinforcement learning, all this thing has actually in the picture to act. So this is the very quick overview of the AI. So obviously, every time when you say about AI, this line, the last line we always mention, that the highlighting the significance of AI is mimicking, but not replacing human intelligence. We never say that AI can take place of a human. It is not possible. At least till today's or maybe coming 10 years, we can never say. We don't know what the world will be after 10 years. Like the movie says, okay, I don't know. We don't know what will happen, but till now, or even upcoming 10 years also, we can see the future. It can mimic the human, it cannot replace the human. Now, quickly evolution. So in the 1950s to 1980s, they are basically rule-based or symbolic logic. There's a fuzzy logic. So then rule-based systems, these are there. Okay, so chess program. So in the chess game, what we have some rules. Based on the rules, the horse will move, the elephant will move, all these things. They will have a specific rules, and based on that rule, the games will be played. Next, 1990s to 2010. Okay, so in that time, machine learning was there. So that time, but the problem was that time deep learning was not popular. That time machine learning was there, AI was also there. But again, the problem is with the computation power. In 1990s, even I think 2005-6 also, I think one pen drive of some megabyte is cost in 10,000 or something MB. Okay, so forget about GB or something. So it was very costly. At that that time, 10,000 means very, very huge amount. Okay, so if data storage was so costly, and I think 2002 or 3 that time in India, mostly the smartphones have come up. That time only. So that time we have a very big mobile and with a very limited any processing power. Forget about data processing, normal processing powers. So again, in that case, we will say that it was really the progress of machine learning was just the algorithm. It was come in the pen and paper. It was in the books, but not actually in reality. In the late, I will say in the late 2010, I will say that time the machine learning algorithm has started to evolve actually. In the 2010 to 2015, that time the machine learning algorithms has quietly evolved, because that time the both the processing power as well as storage has become quite in good shape. And 2015 onwards, deep learning has actually captured the entire market, because as those who already know, for them it's fine, but I will still want to say what the basic difference between machine learning and deep learning is. Machine learning has has two parts. Basically, one is learning from the data. Another part is we, as our users who are actually designing the algorithms, give some input, rules, or some statistics. Based on that, the machine learning actually do some prediction or classification, whatever we say. Okay, but in deep learning, we entirely depend on the data itself. So which one is good and bad? So we cannot say anything, this is good, this is bad. Okay, but there we can make a comparison. So comparison is, let's say we have a small amount of data. So if a small amount of data, so obviously in that small amount of data, we have not covered all the boundary conditions, right? We cannot say that all the things. Let's say we are saying that we are making a designing of the let's say there is a old age home, and there people are there. So we have a camera over there, and we are just monitoring them so that anyone should not be fall down. If someone fall down, the caretaker should run and come to that place, something like that. And it is an old age home. So we cannot say that this way, if you fall, then only it is a fall. If you other way fall, it will be not be a fall. So that means if I have to say that, then all instances of data falling should be there every way, every possible way, right? But if you don't have that, then what will happen? That if it only learn from the data, it will be very difficult to learn, because it will not whenever with the data that with that type of fall, if it is not present in the data, then obviously it cannot detect that it is a fall. But let's say, but if in machine learning we have some statistics. We said that if this type of walk is pattern and the statistical model says this if this equation is not fulfilled, then this type of equation are not fulfilled, then maybe you can say it is an abnormality. So we can give like that. But the challenge is, can we give all type of fall in a statistical model? Can we actually model every type of things in a statistical model? Can we do it? No. We as a human, we cannot actually do statistical modeling for everything. We will obviously leave something, because there are so many anomalies. We cannot capture all the anomalies, all boundary conditions. But if there, let's say for 10 years, they are not predicting, but the camera was there and the data has been captured for 10 years in the old age home. And all the data we don't have to do, we just feed into the machine itself. That's all. We just feed it. And the machine it will itself learn it. Then obviously it is highly likely that above 90% anomalies has been captured over there over 10 years data. So again, in both the case, we have some good and some bad. The bad means I will say positive and negative things, and we have to decide where to use machine learning, where to use deep learning. But nowadays, since data is free and there are a lot of data always circulating in the internet, so we always prefer to go for deep learning models. Now, for so deep learning means deep neural network. That is the neural, which is extended from neural network. Neural network is always existing in the AI also, but that time it was not popular. When ML come and then the processing power as well as the storage power has been increased, it become a deep neural network. And from deep neural network, it become convolutional neural network. It become a graph neural network. It become reinforcement learning. All these things has come after that. Lot of other things has come actually. But starting with the neural network, which has been long, but in 90s actually it was there. But we hardly read them as a part of the book, in the book of the AI book as a neural networks. Okay, because it was not at that time, it does not have its power to actually being used in the real-time systems. But now it has, so it has grown like exponentially grown, not just linearly grown. It has grown exponentially. Now, type of AI, again, narrow AI, that is we call weak AI. So specialized in a single task, like Google Translate. So currently I am actually in South Korea actually. Okay, I'm in university here as a visiting professor. So here all the people talk about in Korean. They don't understand our language. Even they don't understand English. Okay, 90% people do not understand English, apart of the professors here and some students. So truly speaking, most of the time I used to actually open there are two apps. One is Google Translate and another this Papa app. There's another app actually. So the Google Translate, wherever everything is written in Korean here, everything, nothing is written in English. So everywhere when I go or see or like any product I'm buying, any shop I'm seeing, first thing I do is I just open the Google Translate camera on the Google Translate and check it what is written there. Any product I will buy, first is what is the ingredient on it. So I just want to check it. I just want to Google Translate on the camera and check it. Okay. And there is another app that is that app is like there is a conversation app. It is basically a conversation app. So I choose my conversation as English and their conversation as Korean. So whatever I say in that conversation, they translate into Korean, and whatever they say in Korean, they translate to English. So these are specialized for one task, but they're very efficient because they're only specialized for one task. So specialized to one task is the application domain is very, very narrow, but they are very strong in what they are doing. Okay. Next is general AI. So general AI means it will at least cover few things, not just one thing. So hypothetically, AI can capable of general human-like intelligence and problem solving. Like let's say ChatGPT. Okay. So normally it is actually a language. It's the language tool. No. So it should rewrite the language properly and do these things. But still, we can ask question. It search from the internet and give you results. So it has. I will not say it is very efficient, but it can actually do many of the things. Not all things, but many of the things. Now, super AI. So, like the example it was given is like fictional example was Jarvis from Iron Man or Samantha from Her. Okay, they are like. Okay, in Iron Man, you see the Jarvis can do like what are the news there is, what type of guns are required, everything they can have. He can actually calculate. The super AI is like supercomputer kind of thing. So like AI suppressing human intelligence in all aspects. So that is obviously it is very distant future, and we are not expecting that it will actually happen. Maybe if it is happened, it's really a very big thing. Now, how AI works. So this is the basic thing. Whether you go for ML, you for DL, or you have to go for RL, whatever you go. But this is if it is a AI based model, then it will actually follow this thing. So first is data collection. So without data, even it is ML also without data it will not work. We give statistical and rule based or statistical analysis, but data should be there. Data analysis should be there. DL there is completely on the data. If it's RL, we have to give the instructions. So what are the instructions for reward? What are the instructions for punishment? All these things. So I will come to RL in the next lecture. In this lecture, RL is not, because for day-to-day activities we don't much use the RL, but in transportation we use much the RL. So we'll come there. No, so first is data. So data is gathered from various sources like social media, sensors, or user input. So social media, like if you are working on social media data, then obviously this there are like Facebook, Instagram, and Twitters and all these are the huge amount of data is flowing always in this social media networks. If let's say you are doing yoga or something, it's not always that you have to do camera based. You can use some sensors, body sensors, right? You can affix some body sensors on you and just tie them and do the exercises. It will actually capture your entire posture. Or you are cycling, or you are doing something else. So the sensors are sufficient for them to capture your activity. Or user input. Let's say you are doing something and you are giving some input as well as you are capturing it. Because so that there should not be any miscalculation, you are also giving some user input. Like say you are in the chatting, you are giving that I am doing this thing, and then you are actually uploading the image like some captions. You do, right? When you do upload some images or in the social media, you write some captions. So that is user input. So to give some hint that okay, or some reel you have uploaded in the social network, and obviously you give a caption on that. So that caption is basically a user input that took hint so that people not get much diverge, right? Next is model training. So machine learning or deep learning models are trained on the collected data to recognize the patterns. Next, so AI can learn to detect spam mails, and these are just an example. Then it's decision making. Finally, what you want to do? You have to predict, you want to classify, you want to regenerate. The generative AIs, you have to regenerate something. What you want to do? So something you have to do, right? So decision will be then. Something you are doing. So algorithm analyze to input and take predictions or decisions. So something you should have come output, right? So that is called the decision making. Now is continuous learning. As you increase, as go on, so it will not be from one data, it will not be happen. You add on data, it should be actually updating itself. That is called continuous learning. Feedback loops improve the AI performance over the time. So always we say that it will be chunks of data and we'll improve it. And another chunk of data when it comes, it will again improve it. So there should be a feedback loop so that the data the performance should be improved over the time. Like the example here, the example is good one. The Google Maps refines route based on the real-time traffic data. So we say that normally it at first what he gives the Google is first normally he take the last 3 months data and he give a normal prediction that what is the distance of this and what is the probability. But if in the real time there is a congestion, there is something going on, there is a rally or something, it will and it was actually getting the, let's say in a very small area there are more than 1,000 people. It will actually incorporate that. Not only it will just give you the result out of that 3 months data, you will also include the real time data over there. That though it is from 3 months, it was actually clear, but now I can see with a very small area, it is more than 1,000 people are there. That means some issue is there. So it will go you a continuous blinking with a busy area. Okay, so that means it was actually incorporating the previous data as well as the new data. Any questions till now? Okay. So now we will moving to the machine learning now, because we are almost wrapping with the AI part. So what are the examples we have? Like smart assistants, like Alexa, Siri, Google Assistants we have. Okay, these are the smart assistants we have. Now as I said, here only after coming, I come to know that app. There's an app called Papa app, then which actually help to multi-language conversation. Then healthcare. So AI assisting doctors in healthcare in lot places this AI is being used actually. Like all this type of microsurgeries, they are basically assisted by the AI. So then personalized medicine, diagnosis, transportation, there are a lot of places, like whenever you transport this okay, I'm not saying autonomous driving, because self-driving it's obviously it is still in testing, but apart of that also, like we have that the searching paths. And not only that, we multi-functioning of different things, like when the call will come, your audio will be minimized. Okay, it will automatically detect it. When your Google Map will say something, take a turn, the song which was playing will be minimized, because that is more important. He knows that if Google is saying something, Google Map is saying something, that is more important. These type of things are always there. These are the small things. Obviously, we are expecting another 10 years, the self-driving cars will be very popular, though it is in test in many places, but still it is not in actual use. E-commerce, recommendation engines, that we can see 100 times, right? In Amazon or in other Myntra and all these shopping sites, we can see if we not only just recommendations, we can see direct recommendations. We can see that if you buy a bag, it will say try the keychain and all this thing with it. You will give a recommendation of other thing that other people also buy. If who is buying this thing, also buy these things. So these are the recommendations always come. AI is not just technology; it is a way of regaining the world around us. Now, machine learning, the heart of modern AI. So now, from AI, we come to the machine learning. The first thing that comes is machine learning. From machine learning to we have deep learnings and other things. The first is machine learning. So machine learning is a field within AI where machines learn to perform tasks by analyzing data and recognizing patterns. So obviously, in AI we have rule-based. In AI we have statistical things. In AI we have many other things. We have just fuzzy logics. We have all in AI. But when you can machine learning, that means it's learning from data. It is now very quick. We have learning from data, particular patterns, anomalies, non-linearity, all these things we are actually learning from the data. Maybe we give some input, we not give input, that is a different thing. But learning from data should be there. Analyzing and recognizing patterns from the data should be there. So unlike traditional programming, ML does not rely on fixed rules, but adapt and evolve based on the new data. So whenever we learn from data, that means whatever the data is coming, still we will adapt with that. Will not just based on the previous rule-based, like fuzzy logic or other rule-based methods are there, will not believe on that. Rather, we'll learn ourselves, we adapt ourselves based on the data that is coming. So engine behind intelligent decision making. So that is we call in a very short as a machine learning. So traditional programming struggles with tasks requiring adaptability or extensive data processing, such as predicting consumer behavior, recognizing objects in image, detecting fraud in real time. These are examples. So what happens is, in traditional process, if the rules are not perfect, if the rules does not cover everything, what will happen? It will actually cannot predict all the when it is just only in rule based. It cannot predict the things that are happening in real time. But when ML comes, we have data. So obviously data, even we are taking the real time data also. So that means we are also capturing the context. Context means, let's say if let's say there is a strike, or there is some agitation is going to be happen. So obviously it's not like one day the agitation will happen. Let's say there is a strike or something is going to happen. That means some political issues or some issues. Let's say it's going on for a few days, and then only the strike will come. So that means if we capture the context of the last few days, we'll understand that something may be happen. So that is what we call that only if you rule based, yes or no, or maybe multiple or even options also. Still also it is very difficult to say only on rule based. But if you add up, because again all the things are not based on the rules. So when it come to ML, obviously it is much better than the just fixed rules. Now, ML fills a gap by analyzing vast amount of data, learning patterns, improving predictions. ML helps us to solve problems too complex for human designed algorithms. So obviously for human, maybe we are obviously intelligent than machines, but we at a time, normal humans cannot consider all the points together. But machine it's a high computing power machine, right? So if you give all the possible things to them as in the form of data, it can analyze. There's nothing to them to analyze, so they will analyze. They have an analyzing algorithm, so they will just analyze. Okay, and once they will analyze, they will give a prediction out of that. So obviously, the complex things that we may miss can be easily solved by the ML algorithms. Now, key features key features of machine learning is data-driven approach. So data-driven approach means ML systems learn from data instead of relying on explicit programming. The quality and quantity of data directly impact the model performance. So as I said, see here ML means including ML and DL. Okay, I'm just saying because ML obviously DL comes as a sub part of ML. So I'm just describing it as a overall as a ML. So here MLs, that's why I'm saying it depends on the data and how much data you have. That really plays a big role. So if you have a very less data, it may go for overfit model. If you have huge data, obviously it will learn all the things, all the boundary conditions, and finally it give an output, and which will be a very robust model. Even some noises will come, even some anomaly will come, your model will never fail. So the size of the data depends. It matters a lot. But again, when the size of data increases, your computational power should increase, your storage should increase. So normal simple machines, or let's say CPU-based machine, or even low-power GPU-based machines also will not work. Then you need a actually server-based GPU. So again, there are always pros and cons in everywhere. Automated pattern recognition. ML identifies hidden patterns and trends in data without human intervention. For example, a banking fraud detection system recognizes unusual spending behavior that indicate potential fraud. So this example says that, let's say in a bank there are 10,000 users. So for even 10 people also, it's not possible to monitor all these 10,000 people behavior of monitoring every month, every day. But for a machine, which is using machine learning or deep learning algorithms, it will be easy. Just we have to feed each and every person's data every day to the model and let it learn every day. And if it's found any distraction from the normal behavior of that person, it will actually say that yes, there's a distraction. Might be we can have we have to monitor that person, that some legal or illegal things is going on. Next is adaptability and scalability. So ML models improve as they are exposed to more data over time. For example, a voice assistant like Alexa or Siri improves understanding of assets and commands as more users interact with that. Forget about more users. Even when we also speak, I don't know if you have tried. I personally tried with Siri. So initially, when in the first few days, when I itself talk, it will take maybe 50% of the words. But after a month, I will say, even after a month, it can take anything. It can, any word that I will say, it will start to take it. So multiple person is always there, even for a single person, because we do not always pronounce the same word in the same way. It's not like that. It depends in which condition, what tone, what emotion conditions we are. So we will not speak the same thing in the same way. The pronunciation gets changed. I'm not just saying the emotion, the pronunciation also gets changed. So they actually learn day by day as you over the time, the data that you give. With that, when it find that at least 50% or 60% match is there, that means it's you only. So you'll learn itself. If it's less than 50%, then obviously it will take someone else's thing. So you'll not take the data, not take that. Take your command. But it is more like 60% match is there, the same word, but in same net, complete different accent or different pronunciation. Still, it will take, and it will learn that maybe sometimes you say like this, or sometimes you say like that also. Now, key features of machine learning, some more features we have. So, versatility across applications. So, ML can be applied to diverse fields such as healthcare, finance, entertainment, and agriculture. For example, prediction, weather condition, or diagnosis disease. Now, the ML algorithm, mostly if you see like DNN models, let's say, convolutional neural network. The convolutional neural network is not made for only for predicting weather condition. That network is made or for diagnosing disease. Same network with the change of data and tuning the parameters, we use many ways. Let's say there is a AlexNet, or there is a VGG16, or there is some other YOLO model. All these models are not fixed for particular application. No, it's not like that. These are the models, are the generic models. Or let's say in machine learning, we have AdaBoost, we have a decision tree, we have many other SVM model. So all these are not, okay, the SVM will do this thing. No, not like that. They are the generic models. When we use for a particular data, obviously we use to tune the parameters so that it can be used to with the data that I'm accessing there, on which I'm learning it or predicting it. And then we used to train it and finally get the result. But the algorithms are generic. Then predictive capability. ML algorithms forecast outcomes based on the historical data. For example, stock prices prediction model uses past market trends and news to predict future stock markets. So as I said earlier, there's a let's say there's a surgical strike, or there is some issues are going to be happen. Here also like there's a stock crash or something. Obviously, it will not a single day or something will happen. Just immediately the stock prices crash and something is going in the market in last 2-3 days. Based on finally the stock market crash, or the stock might get a big hike. So that thing, obviously, first of all, it's taking the future past data for long time, historical data, and also the current context and the agitation what is in the data. What an agitation means, it's a non-linearity in the data. So that is also captured, that this type of non-linearity has come up, which was not there. So that means something will going to be happen. So it will and what will happen? It will see in the past data that if this type of non-linearity have come sometime in some instant of time, what type of outcomes has possibly has happened in the past. So based on that, he will say maybe tomorrow or day after tomorrow there is a crash or there is a hike in the stock market, something like that. Next is real-time decision making. So many real-time system work, or many ML system works in real time, making instant prediction and decisions, like autonomous vehicles process sensor data and to avoid collision instantly. So there are this back cameras in the cars. Okay, I'm not saying autonomous vehicles because again there are a lot of things will come, but like UAVs, or let's say the back cameras of the cars. They have a lot of sensors, like they have proximity sensors, they have touch sensors, they have a lot of things, sensors are there, they are touched, and they give alarm based on that. So obviously, how they are giving, they are not only just giving the alarms, but just because it's present. Obviously, they are as the sensor present, the data has been collected from sensor data, and they are processing the data, and based on that, it was saying when the alarm should be built and when the alarm should not be built, right? So real-time decision making, so that must be, that is actually output. Now next is customizable and domain specific. ML algorithms can be tailored to meet specific use cases or industry requirements. For example, personalized fitness trackers recommending workout based on the user data. As I said in the beginning, let's say let Google Translate, okay, just I said, or that conversation app, okay, if it started doing a lot of things, maybe its accuracy actually decrease. But it is very targeted to one work. So it is learning over the day, night, and years. Over the time, it is learning for only one task. So obviously, it will have a very good computing as well as predicting power, because it is not diverse. It is very narrowed down and very focused on one particular work. So when we have to generate revenue, let's say, or we have to, let's say it's a surgical, it's a medical thing. There is some surgeries going on. We cannot use generic algorithms over there, because a surgery means there may be fatality can come. There may be some bad thing can happen if there is generic things. So we have to take very precise things. So in that cases, we actually need algorithms which are tailored, which are tuned to do a particular task, and which has been trained for over years. Okay. So here is the example is a fitness tracker. The fitness tracker is only, you say that your movement of doing the workouts. So because a single workout can be by 100 people can done by 200 ways. A single people can do the same workout in maybe in 10 days in 10 different ways. So still it will say that it is right or wrong. So if it is tailored particularly to do the fitness tracker to do that thing, it can actually do it a more better way. Continuous learning. So model evolve the changing data patterns, staying relevant even in dynamic environments. As I said, the Google Maps and all this thing, already I have discussed it, that as the environment also change, it will not just depend on the historic data, it will also take the current data, dynamic change in environment, and give the output. So online retailers updating price strategies using ML to match the competitor pricing trends. Now error reduction over time. Though training and tuning, ML models minimize errors and increase accuracy. For example, OCR, like optical character recognition system, become more accurate in digitizing text from scan images. So though it's now this OCR is become a very old technology now. Any mobile, any I will say more just average smartphones can do OCR a good way if you just focus, give a proper focus on that text. But still, so as we said that let's say there's a letter I. So I can be I can be one, I can be just a slash. Okay. But if you read thousands and thousands of data, okay, then obviously the errors of finding which is actually it's I or it's not I will be better, and as the errors will be minimized, the accuracy will also increase. So as I saying that if you use Google Translate, I don't know how many of you just use it, try it, just try to translate the Hindi to English. You will see it is giving really fabulous. It can convert each and every word. It is so helping. Here it is helping me a lot actually, truly speaking. So because here in Korea they don't use English also. Even their computers are also in Korean language. So forget about food, store, bus, trains, forget about them. Even the computer itself are completely in Korean language. Even if you search something, it will give the results. There is no option for translating until and unless complete OS from in the OS itself you have to go and change it. Anyways, their website, their apps, all are in Korean language actually. But the until this Google Translate is really working good over here. So it is focused, it is learning, it is obviously it is also actually minimizing the errors over the time, because taking different type of character, different type of manipulations and increasing day by day. Obviously 10 years back the Google Translate was not so good. If anyone has tried it, you can see it is not so good. It is giving something a bit, but now it has become very good. Now the last slide on this is integration over technologies. So see, only just we will not say it is only just we will do the will not say that that ML will just as a separate algorithm it will work. No, it can be integrated with the Internet of Things, big data, robotics. So if we cannot integrate with them, then obviously it will not be that useful, right? Only running them in the some system, it will not be useful that much. Maybe it will be useful, but not that useful. But now if we say if you have to make end-to-end products, let's say we want to make a smart pen for the kids, for kids writing monitoring. Obviously, only the algorithm will not say, the algorithm will say the pattern, but who will capture the data? That means we need some sensors. The sensors are integrated. Sensors are integrated in a pen to capture the hand movement of the kid to writing the data. And along that, the gesture of the kid is also being captured by some camera or something like that. The gesture that is playing, or by the sensor itself, we are capturing a gesture, and then we have to send the data to some, because that pen itself will not have a processing power. So we need some Bluetooth or something, some communication technology, Bluetooth or Wi-Fi, that will send it to some maybe even not, if not server, maybe in mobile phone, nearest mobile phone, and from mobile phone it will go to the server, that who will actually analyze that what he is writing. He is writing A or he is writing B. The kid is writing A or kid is writing B. So that means integrating these ML algorithms with IoT, obviously it can give an end-to-end product. Only using ML just in a system base it's hardly, it will give, like if it's just Google Translate or something, that is app based, that is fine, but always it will not give an end-to-end products. Similarly, big data or robotics, obviously robotics use a lot of places of AI ML. I don't have to say it, because completely robotics depends on the aim. Otherwise, there is, see, mechanically used robotics will not have any much use. That will be used in the factories. They have routine based, they have rule based, and that's it. But when you say robotics, when you say humanoids or something like that, they must have some AI. They have some decision making power. So smart thermostat adjusts home temperature based on the user preference and weather forecast. So let's say it is a weather forecast, and as well as you're feeling hot or you're feeling warm, let's say, or something like that, and you say that it's really warm. So it will say, okay, normally if you say warm, you prefer this type of this temperature. Maybe you prefer 20-degree temperature. So it will try to adjust like that. You don't have to say make it 20 or make it 21. Last is, so adaptability, scalability, and automation. These are the three key aspects. we have discussed a lot of things, but the three key aspects are adaptability, learning, and improve over time. And with a huge amount of data, scalability handles vast amount of data efficiently. So as the data will come day by day, it can scalable. It can actually accommodate it. Automation reduce the need for human intervention in repetitive tasks. Obviously, if it is not decrease the human task, why we are going to use AI/ML? If we also still have to do a lot of other work, then why we'll go for it? We will not go for it. So it should actually decrease the human efforts. Now, machine learning process. So machine learning process, these are the 6 steps we have to follow, always follow. First is data collection. So it's very short we have written. Again, when you come for each and every algorithm of the machine learning process, then how this will happen, these things will come. But just in a very short, it is written. First is data collection, then data pre-processing. Now, once you collect the raw data, it will have a lot of noise. It will not be in proper format. It will have a lot of things that cannot be given to the machine. If it can be given to the machine will get puzzled. So obviously, we have to clean and transform the data in a particular format, that which is readable format, properly readable format for the machine itself. Then model selection, that for this amount of data, for this purpose, for this prediction or classification or regeneration, what we are doing, what type of model will fit. So that selection we have to do. So that's choosing the right algorithm. Next is model training. Now we have to train that model on that data that you have filtered, clean and formatted and given to the machine. Finally, evaluation and testing. There should be some parameters. There should be some accuracy parameters or robustness parameters. Some parameters will be there. Based on that, we test that whether the data in the test time, how much good the training has been happened. Finally, deployment using the model in real world scenarios. Now, only doing in pen and paper or doing some programming is not sufficient. Until and unless we use in real life. So there should be some deployment of the model in the real life scenarios. Any doubt? Now we are going more on technical things. Okay. Now, supervised learning. So first thing, for the day-to-day activities, we basically cover two parts, supervised and unsupervised. Here, because most of the day-to-day activities we actually cover under supervised only. Okay. Like in the next lecture will come from transportation. There, most of the things work on the unsupervised and reinforcement learning. Supervised also work, but there are a lot of works also which where unsupervised and reinforcement learning also take part. But in day-to-day activities, activity or action recognition and detection kind of thing, basically supervised learning plays a major role. So supervised learning is a type of machine learning where the model is trained on labeled data. So main word is labeled data. In other words, the training dataset includes both input features and correct output. The model learns the mapping between the inputs and outputs, which allows it to predict the output for new unseen data. So basically what happens is in supervised learning, we have the data. For data, we have the features. That what are the features? Let's say it's apple. So apple should be near round, it should be red, or it should have been particular this apple shape, something. These are the features. Also, it will say that this is apple. It is not like that it is the shape is like this and color is like this. You can do anything. So no, it should say this is an apple. So that label should be there. If it is orange, so it will say this is an orange. So not only the features of an orange, that it should be round, it should be color of orange or yellow or something, or greenish yellow. Apart of that, also it will say this is orange. So that is called the label. That someone has said that yes, this is the orange, this is the apple, this is the cat, this is the dog. Someone has said that. So apart of that, we have the model learns mapping between input and output. So basically we say if it is a classification problem, let's say first we say classification. If it is a classification problem, then obviously in the test, so training time we are training it. Validation is within a part of our training where we are checking that whether the training has been done properly or not. Testing, during the testing time we have no label. We'll predict the labels in the test time that what if some a fruit is given, whether it's an orange or it's an apple. So that output level, the output will be calculated, would be classified, that fruit will be classified as either apple or an orange, right? So basically what we classify is a map of the labels that were given for that particular fruit. So during the training time, we give the labels to learn it. In the test time, we are actually predicting that label, or actually we are classifying based on that label, where the labels are not present. So it is called unseen data. That's why it's called unseen data, because the labels are not given. Features we will extract. Feature extraction is not a problem. Feature will extract, but final prediction will be the class. That class is the label, which is someone called label, someone called class. So there are different words the people will use, but basically whatever the class we are during the training, or whatever the label you have given and trained by the system during the training, will from there itself will come for the, as one of the label will come as an output in the test time. So how it works? A dataset with input-output pairs is used to train the model. Input-output means the data and data with its features as well as the labels. So the output is the labels basically, or the classes. Pairs is used to train the model. The model is tasked with finding the patterns of the data to make the predictions. The process involves comparing the model prediction with actual output, adjusting the model parameter to reduce errors using the different methods like gradient descent or something. So what will happen? It will, based on the features, so what will do when you give the data? It will extract the features. In the test time, what it will do? If we give the data, it will extract the features. From the extracted features, what it will do? It will try to predict which is the nearest class to that particular feature. So if in the training time, for each class, let's say 10 lakhs of data, you have actually get the features. Let's say for apple, we have let's say 1 lakh of apples. For orange, you have another 1 lakh of orange images. For let's say for pears, you have another 1 lakh of images for pears. So while during the training, it actually learned, it has make a very big vector or an array, which are the values of the features. That okay, these features there are some values, and they say that these features accumulated described by apple. These features accumulated described by pears. This features accumulated described by orange, like that. Now, when in the test time, so they are now they are mapped one-to-one with the when the training will complete, these features will be mapped one-to-one with the classes or the levels. Now in the test time, first the feature extraction will be done with the model. Now you will check the Euclidean distance between all the classes and the feature extracted. Who is the most nearest to the recently calculated features, and based on that he will give the best one or best two or the one output prediction based on what type of models, what type of prediction we are doing actually. So that is what it's saying, that it is actually output are adjusting the model parameters. So if from all the class, this feature vector, newly extracted feature is very far, the Euclidean distance is very far, is very big, then that means we have not properly extracted the features. So we'll tune the parameters and again we'll extract the features properly, so that at least it should be near to some of this one or two or three, maybe base three classes, right? So that is that we'll do the model tuning the parameters of the models. So supervised learning, obviously, because we are dependent on the data itself, so it needs a huge amount of data. So in general, let's say if I just do an object detection and properly, let's say it has a 10 class, we'll say that it will have at least 10,000, around minimum is 1,000, let's say 5,000 data. Otherwise, for 10 class also, it will not do a good job. And if it is more class, as the number of classes increases, let's say there is a orange and a Musambi, both are almost similar, right? It's very difficult to differentiate. Then obviously for orange itself, it will take maybe 10,000 data, and for Musambi it will take another 10,000 data. Maybe after that you can actually learn this minute difference between an orange and a Musambi kind of thing. So as the number of classes increases, as the closeness between the classes increases, then obviously the amount of data should be increased exponentially, so that proper difference should be in the feature vector should be kept. So once trained, the model can be used to make predictions on new data with similar pattern. Obviously, similar pattern means that the classes that we already have taken from on that pattern only we can do. Now, for example, quick examples are activity recognition, healthcare, spam detection, activity recognition, supervised learning used in many fields, such as activity prediction and recognition. So whatever activities has been performed, like as I give an example on the old age home, right, where the people are, where the elderly people are staying, and if they fall, then it can actually detect that there is a fall. Now healthcare, like predicting diseases based on the patient data. Okay, so like there are malignant and non-malignant tumors are not there. So this type of things are can be easily predicted. Spam, there is a spam or not spam. If it's let's say that mail, this type of mail has been labeled by 100 people as spam earlier. So obviously there will warning will come that to you that it is probably a spam. Even nowadays in mobile messages also come that it is probably a spam message because most of the people have tagged it with a spam. So these type of things are always there. Now regression. So regression in activity recognition, it plays a smaller role, but still we can have a role of regression here also. So regression is a type of supervised learning used to predict continuous output values. So remember, it is main important keyword is continuous output values. It is not classes. It is not labels. So if it is a classes or labels that are discrete, like I have an orange, it is a apple, it is a banana, it is a pear. These are discrete keywords, right? They have discrete words. Or even say let's say I label apple as 1, 2, or 3, then 1, 2, 3 are discrete numbers. Okay, but when you say regression, it is a continuous value. The value will be predicted, not a class. So that means we'll do some manipulation, and based on the manipulation, some value will be calculated here. So regression is. In regression, the model is trained to estimate real valued output based on input features. So important keyword is real valued output. So how it works? The goal of regression is to find function or a line or a linear regression the best fit the data point in the data set. This function minimizes error between predicted and actual values. So like let's say predicting GDP growth based on the variables like inflation, unemployment, or interest rate. Or weather forecasting, estimating temperature, rainfall, and wind speed. Okay, so predicting the student final exam score based on the hourly hours, study hours, class attendance, or past exams. So that means we are basically what we want to say here is we are predicting something. We are predicting the values, not the class. So we are not saying it is a cat or a dog. We are saying that let's say what is the value of the temperature now. What is the estimated forecast of tomorrow's temperature and humidity based on today's all thousands of the parameters that we are taking in consideration. So they are actually real values, not just this. So it will be maybe 12.5 degree temperature, or later it will be maybe like 20.5, 20.2, or 20 degree temperature. Let's say in a round figure. It is not like a bigger like class, something like that. It will be actually a value. So real value output. Okay, so even GDP or estimating temperature or score, all these are values. So basically regression, that's the main goal is here is regression is basically used to actually understand to predict the values. So in stock market, regression is widely used basically. In transport, in the next session, what I will say, there also regression is widely used. So where we have to, but in activity prediction, basically classifications are widely, because we have some activities are bigger things. So we have some activity classes. So in activity prediction or activity recognition, basically we go for mainly for classification. Still quickly, I will give a short description of regression in this slide also, in this PPT also, presentation also. So linear regression, polynomial regression, or ridge or lasso regression. The linear regression means the function that is mapping between the input and the output will be a straight line. So predicting the relationship between input variables and the output variables as a straight line. That's all. That is why linear regression. The equation will be linear. Like A equal to BX plus C. Something like that. I'm just saying something like some linear equation, which is not x squared or something exponential or something logarithm will not come. It should be a linear equation. It is used when the relationship between the input and output is assumed to be linear. Predicting the house prices based on the feature like square foot and number of rooms. Let's say we say that okay, number of let's say in a same locality, all the houses are of same price. So obviously, how will difference it will be based on what is the size and how many rooms, maybe 1 BHK, 2 BHK, 3 BHK, and what is the total area. For 1 BHK, maybe someone has 500 square foot, someone may have for 1 BHK itself for 1000 square foot. So based on these two parameters, there is a linear function has been made for to predict the cost. So that is a linear regression. But if the function is not linear, it's a polynomial like x squared or x cube has come. Extend the linear regression by using polynomial function to model the nonlinear relationship. Then it will be obviously a polynomial regression. So modeling with growth rates are nonlinear but quadratic and cubic. So obviously these stock values and all these things are not linear. The stock market, especially where the regression is highly used, okay, they are never been linear. They're always non-linearity. There are a lot of things that depend, and there's a lot of hike and there is a fall also based on this non-linearity present. Now region lasso. So these are the advanced techniques to improve the accuracy by adding penalties to the model to reduce overfitting. So there are here the rewards and penalties are there. So that the it can be so that the values can be calculated more based on the real-time data. So predicting house prices with multiple features like square foot and number of rooms, where ridge regression prevents overfitting by shrinking the large coefficient. If there, let's say there is a coefficient is very large, we'll okay because and that is actually biasing the entire model because that is playing a major role. Then it will actually shrink it, doing some penalty on it. Lasso is like predicting the customer churn. Lasso regression selects the most relevant feature by shrinking less important features coefficient to 0. So it will actually nullify the less important features so that the prediction should be done in real time, in lesser time. So I'm not going much details here because again we'll discuss this in the next presentation. Now we'll come to the classification. Yes. So classification is a type of supervised learning where the goals is to categorize. So as in say labels or classes, that means categorize. Categorize input data into predefined classes or categories. Unlike regression, classification deal with categorical output. It's not a continuous output, it's a categorical output. So in classification, the models learn to distinguish between different classes by identifying patterns in the features of input data. The output data is labeled as spam or not spam. So obviously apple or orange, like spam or not spam. We have a discrete value, discrete classes, not continuous. The model is trained on label examples and is evaluated based on its ability to classify new unseen instances. So one new fruit has come, we'll see which one is there. So the feature vector for the new one, the new fruit is matched with which of the fruit that is already in our training data. We'll classify him into that. So it is used in a lot of places, healthcare, marketing, and apart of the activity recognition, there are a lot of places it is used, like diagnosis disease, categorizing customer into segments of targets of advertising, a model classifying animals, cat and dog, all these things, a lot of places this supervised learning is used. Now, what type of classification can happen? First is binary classification, like spam, not spam. This is just a binary classification. Either have or not have. There are two classes. But anyway, nowadays, there are hardly few things are there where we use binary classification. But it's a very basic, simple one. Someone want to try, first time when trying some supervised learning can start with a binary classification. Next is multi-class. That is one, the example I have given is the fruits, the apple, banana, orange, pears. Their classes are more than 2. So that is called multi-class classification. Involves more than 2 categories. Next is multi-label classification. So this is basically we mostly use when we do some real-time problem solvings. Okay. So here it is basically is hierarchical. That means let's say we say politics, international economy. This type of tagging you have done. Okay, let's say there is some article in the news and they are tagged with this. Now politics can have multiple tags. The international can have multiple tags. Economy can have multiple tags. So just it's not like a one tagging. first in the level 1 it is tagged with 3, and again in the level 2 when you go for the let's say we take the first tag and it have multiple again this first tag again have multiple subtags. So it is multi-level classification. So it's a, let's say we say that let's say there is a fall and non-fall. You are walking and fall. Now if you say fall, what type of fall? It is a walking fall, it is sitting fall, it is a lying fall, what type of fall? So it is again fall and non-fall is the first category, and in the category itself there are subcategories of what type of falls are there. So this is just an example. There are many examples because we mostly use multi-level classification nowadays. So common algorithm is logistic regression. So logistic regression is basically, though its word is regression, but it is basically used for binary classification. So though it comes with the word regression, but it is basically used for binary classification. Then decision tree. So it is tree-based classification. So everything it will make a tree. So I hope you know that the trees, right? Graph, trees. This thing I am expecting that you know in the computer science there is a course called graph, right? There is a trees and graphs are there. So how they have nodes, they have edges. The nodes are the things that exist. Real life that exist called the nodes, and the edges are the function that connect the nodes itself. So like that, if the tree means that is called a graph, and if this tree means the graph that does not have any cycle. These are just technical definitions. Okay. So in a tree structure, so decision tree is the tree like model that split the data into smaller subsets based on the features. Now support vector machine SVM finds the hyperplane. So it basically use hyperplanes for the best that best separates the data point into the different classes. So it has it continuously minimize the hyperplanes from the feature vector, and based on hyperplane minimization, it use which class it belongs to. Next is random forest. So random forest is example method of using multiple decision trees. It is not just one decision tree. You take multiple decisions, and finally, based on all the decision tree decision, it will take the majority vote or something like that for final classification. So these are the methods. I am not going in details in case if you need, because all these have now these have become very common. So just anyone can actually Google it. You will get a lot of material in the internet itself. But anyone still, if you have any doubt, you can ask more in the end. You can ask me. I can explain it immediately. Okay, but since we have limited time, so I'm trying to go into the where machine learning, deep learning use in the activity recognition. So supervised learning, the challenges we have basically is data labeling. Because it is supervised, so you have to need people who will label the data. So it is time consuming as well as expensive, because we have to pay the people for labeling the data. If they label, and it might happen if you take the data from the internet or from the social network, it might happen people have tagged it wrongly. So that is also there. So this type of issues are there for data labeling. Then overfitting, where the model performs well on training data but poorly on new data. It's said to be overfitting. That means that the model becomes too complex and learns the noise or the irrelevant patterns in the training data. That means you have not properly filtered it or pre-processed the data, and you have learned it. So now you have learned from not only the actual data but also noises also. So whatever you are giving, it was actually giving the new data, it was fitting somewhere and giving some wrong result, because you have learned the noises also. Okay, solution is regularization technique, cross validation, simplifying the models. There are a lot of techniques are there. We have to try and we have to check which one will work good for what. Underfitting issues are there. Like underfitting happens when the model is too simple and fails to capture the underlying pattern in the data. So you have, let's say you have a very big data and you have given a very small model, like let's say VG16, which have only 16 layers. It actually cannot able to capture all the non-linearity present in the data. So it will make big bins and say, okay, all the features are in this bins. All the features which though they have a lot of non-linearity, still I'll map it in one bin, and it is actually not. So it was actually underfitting. So this leads to a poor performance both training and testing time. To use more complex model and provide more features for learning. So this is a solution. So obviously here we have to. It is a very important when you actually train using supervised learning, what type of, based on the data, first the programmer should decide what model it's for. I will not say one model, but what type of model should be it fitted. If you start from anything from the scratch and doing anything, then you have to try a lot, and finally you get something which is actually optimized. But if a programmer who is have a bit knowledge, he can give a maybe 2 or 4, let's say 4 models. This out of this 4 models, someone should give, because from the data, as I analyze, this type of models will work. So that analysis will actually optimize the time a lot. Now, imbalanced data. So let's say there are 5 classes. For 4 classes, the data is 1 lakh per class, and for one it is only 10,000. So obviously data imbalance is there. So in that case, what is the solution is there? We have to generate synthetic data for that particular class. Otherwise, what will happen? It will be biased for that 4 class, and the 1 class will always be overlooked, because that feature extracted for that class is very weak. So whenever the unseen data will come, it will not go for that particular class. So if we know that, so that's why I'm saying the programmer should look into the data before actually running some algorithm over it or choosing some model. So he should look into the data and then decide, okay, this 4 or 5 I will try one by one, and let's see which is giving the best performance. So this is also one of the issues that we have to check while looking into the data. Then scalability. As the data set grow larger, the computational resources needed to train increases significantly. So obviously, if let's say I take a 10 lakhs of data, I cannot use it in a CPU or some GPU-based laptop. Obviously, I have to go for a server-based GPU. So that we have to know how much data I have and what type of things we will use. Is it Google Colab sufficient, or you have to actually go for HPC? So that we have to know. If we are just if we are run it and it is continuously giving segmentation fault, then there's no use, right? We should know that segmentation fault means that data, it cannot take the data. So it cannot, because it does not have that sufficient computation capability. So these things the programmer should know, that so that he can get the result in least amount of time. For example, it's like in a sentiment analysis project, if the data set is heavily skewed toward the positive reviews, the model might always predict positive sentiments, resulting in poor classification of negative sentiments. So it will get biased. So all are saying good thing, and there is very least number of negative sentiments. That means it's obvious that the model has trained only with positive sentiments. So even after that, in the unseen data, if you give negative also, it will not able to understand. Now, unsupervised learning overview. So unsupervised learning is a type of machine learning where the model learns about data that is not labeled. So here now we have the data. We can extract the features from the data, but the labels or the classes are not present. These are not present here. So we have to do some mechanism based on the features. We don't have the labels, but we have to cluster them together. These are similar. We don't know it is a fruit is given. I don't know it is an apple or the orange. But based on the features, I can say all these images are of similar features. All these are look like, let's say, shape, let's say texture, let's say color, and based on that, I said these are similar, that are similar. So because there's no label, so I can never say this is an apple or this is the orange. But I can say all these images look like some similar because they are all apple images. So they are obviously they are highly likely they will look like similar until there is a noise. So instead of being given the correct output, as in supervised learning, the model identified patterns, structures, relationship in the data itself. So that's why I'm saying that it will actually analyze more and more on the features itself, because there is no label. Now here the integrity between the labels is very, very high. Otherwise it will completely fail. So unsupervised learning will hardly use in anything, because the accuracy in unsupervised learning is always low. So if you have to go high accuracy, it's not like we never use, but it is high because this auto regression or auto regression models are there. Okay, so that are used in some places, but again or zero shot learning. These are unsupervised learning methods. But again, the output result, the accuracy results for them are really less. So we have to keep in mind what matters. The labels, the effort to make the labels is really required, or we can compromise with the accuracy. So that matters actually. The model processes raw unlabeled data to find hidden patterns, clusters, or associations. There is no explicit target variable to predict. So there is no classes, so there is no target variables. The goal is to organize data in ways that reveals useful information. So that means we have to basically cluster the features in such a way so that it should be meaningful, some meaningful there, such as grouping similar data points or reducing the data dimensionality for easy analysis. So these are the things we basically do in unsupervised learning. So anomaly detection, data compression, okay, then analyzing a set of news articles and grouping into the some topics, because we don't know what will it's just sports or politics, but there are a lot of games are there. Game keyword are there. We can say it may be a sport, though no one has said that it is a sports topic or it is a politics topics. Now clustering. So first thing, main thing is unsupervised learning is clustering. So clustering is a key technique in unsupervised learning that groups data points into clusters. So cluster means groups basically, where points in the same cluster are more similar to each other than those in other clusters. So if there is a lot of data points are there and we make 5 clusters out of it, obviously we assume that the data points within a cluster are more similar. The feature vector of the points within a cluster will be more similar than the feature vector of a point in one cluster with the other cluster will be, right? So they will have a lot of distance. So Euclidean distance between the 2 points on different clusters should be very high, whereas the Euclidean distance between 2 points in the same cluster will be very, very low. So what this is called is intra-class distance and inter-class distance. Intra means within a class. Inter means between the classes. So obviously a good clustering algorithm always look for an algorithm which will generate yes any questions? Okay. Which will where I am? Yeah. So good clustering algorithm obviously look into 2 parts. It will always see that the intra, that is the point within the distance of point within a class, the intra-class distance should be less, and at the same time the inter-class distance, that is the distance between 2 classes, should be very large. Then only we will say that the clustering algorithm is good. This is a parameter to evaluate the model that you are choosing. Okay, not the data. So customer data points with similar characteristics are grouped together, helping the model understand the structure of the data. Clustering algorithm evaluate the similarity of data points based on the distance metrics, like Euclidean distance. Normally Euclidean distance is used, but you can use Manhattan distance or other distance also. Normally Euclidean distance is used. Customer segmentation, like grouping customer based on the purchasing behavior, preferences, or demographic information. Image compression, grouping similar pictures in a region together to reduce the amount of data. Grouping customers based on purchasing patterns, all the high value and regular customers. These are things we can do it. Now we'll come for quickly 3 main important clustering algorithm. One is K-means, next is DB-scan, and finally is hierarchical clustering. So K-means basically is a clustering algorithm. I think many of you have already known the name because it's a very, very old clustering algorithm. Even I will say I before me also it was there in the books, in the AI book, the K-means clustering. So it's a very old algorithm actually. So what it does actually there are a lot of data points in a plane, and it will take the centroid of the data points. It will try to find the centroids and the distance between the points from the centroids. And based on that, the data which will have the, like let's say we have a threshold of the distance which have a less distance from the centroid with the threshold, let's say threshold lambda, they will be in the same clusters. And this here the problem is the number of centroid we have to give. We have to fix. We have to when we start with K-means algorithm, we have to give if we say in the basic K-means, not the advanced K-means, okay? Because many people have now changed it with something more actually, and with the K-means that is in research, okay? But in the basic K-means, we have to give input what are the number of centroids we'll choose in the beginning. And how? Now it's algorithm. It will continuous, it will calculate distance, and the centroid will again update it. Again, because once in the first run make a cluster, it make 5 clusters, let's say 5 centroid are there. And it calculate now it calculate now it calculate the new centroid based on in for each of the initially we have given some centroid randomly. Now when the clusters has been made, then what will happen? It will recalculate the centroid that based on the current cluster, what is the new centroid. Now once the new centroid is calculated, again the distance from each point will be calculated, and again all the data will be moved here to there, and again it will go on in repetitive process. Now where to stop? So for that reason, normally we say if 2 iterations have in 2 back-to-back iterations, there is no changes in the data point, or because that may go to infinite, it might happen there are smaller changes, because if it's a very huge data, then it might happen there is 0.001 changes are there. So other will say, let's say after 100 iterations it will stop, because we'll assume that amount of deflections we can bear. Okay. So segmenting customer in different groups based on the purchasing behavior, where each group represent a different type of customer. So like purchasing behavior means what are things you are purchasing, so that will have a features. These are the features. What are the things you are purchasing is the features of a data point. You itself, here the customer itself is a data point, and what his feature vector is based on that. So now the centroid will be calculated based on the feature distance between all the points like this. So this is the K-means clustering. Now the next is DB scan. So DB scan is density-based spatial clustering of application with noise. Now here 2 points has been covered. It is advanced algorithm, then K-means. Okay. First is we don't have to give the number of clusters that we have to give there, because the centroid means the number of centroid is the number of clusters that you have to give there. Next is it can also able to handle the noises. So DB scan is a density-based clustering algorithm that groups data points based on their proximity to one another. Unlike K-means, DB scan does not require specifying the number of clusters in the advance. It works by identifying dense regions of data points, where a dense region is defined by minimum number of points within the specified distance. The points do not belong to any dense region, are labeled as outliers. So DB scan is particularly useful for discovering clusters of arbitrary shapes and handling noise. So it is obviously a better one. Since we are running out of time, I will be a bit quick actually. Okay. So detecting areas of high concentration of location on a location map, such as finding groups of closely clustered houses in a real estate data set. Like this, like as I said earlier, that if the density is high, we'll make it as a centroid there. We'll not say should be centroid. We'll say if the density is there, it must be a centroid kind of thing. Now it's hierarchical. Hierarchical means it will have multiple levels. It will create a tree level structure, like earlier I said, create a tree like structures. So obviously some levels, and then that some levels must have, they again will have the must have the actually the again substructures. Okay. Now we quickly, I think another 5 or 10 minutes will complete. Maximum 10 minutes will complete. Okay, maximum 5 to 10 minutes. Okay. So okay. So human activity recognition. Now we come to human activity recognition. So human activity recognition and detection and recognition is referred as a process of identifying and understanding human actions or behavior from various input data such as video, sensors, readings, and audio. Okay. Now it can be used in surveillance, healthcare, human-computer interaction, sport analytics, and robotics. So now key challenges. So key challenges are data quality and availability. The performance of AI/ML models heavily depends on the high quality labeled data. Just a second. Yes, anything, Nisha, Dr. Nisha, anything you have to ask, or you are just saying for the time?
No, ma'am. Sorry, by mistake this happened, ma'am.
Okay.
You taught very well, ma'am.
Okay. So now that I will take another 10 minutes, okay, just because this is the important part, so I'm not making it very fast. So because this is the last few slides we have, and that is actually saying how this all the technologies we have read till now will be useful in human activity detection. So now the key challenges. Now earlier we have seen the challenges, but these challenges are related to human activity detection, not for other things. We have to keep in mind. So here the challenges is data quality and availability. The performance of AI models heavily depends on the high quality labeled data. So collecting data across diverse environment. Different. So now when you say cameras, obviously we have a different camera angles. We have different lighting conditions. These are the really challenge. So normally activation either will be camera based or be sensor based. Now camera based is a good one, but given that the camera angle and the camera lighting condition is good. If it is sensor based, it might happen that you have not done a proper activity. Like always we will not see it in a proper way, right? It's not happen. Or always we will not stand in a really standing format. We can tilt, we can do things. So the obviously sensor will take wrong data in that case. So that is the thing. The data should be collected properly. Now contextual variability. The same activity can vary on different context. So let's say someone is doing push-up. It is not falling. But otherwise, maybe a person doing something like that, maybe walking and just fall down. Maybe he can, if you take a partial activity, it might look like this is doing push-up. So again, the context matters. Where it is doing, if it is and how it is doing. Previously, what he was doing also. Can you please mute yourself? Dr. Nisha, your is not mute. Please mute yourself. So next is occlusion and clutters. Now when it's come for camera based, obviously occlusion and clutters matters, because something is coming, people are going and coming, and you bend in such a way that your hand posture is not the data of the hand posture is not in face of the cameras. All these things matter. So obviously occlusion and clutters matters a lot. Next is real-time processing. So many applications such as surveillance. Obviously, surveillance will not say that you do it today and tomorrow I will do a huge processing and give you accurate result. No, surveillance means within a few seconds you have to give a right, whether there is some introduction or something, whether a theft is going on or not, whether someone is coming with a gun or not. So and obviously he will not openly come with a gun. He will hide it, right? So a person who is looking abnormal, doing some abnormal things. Okay, so that should be in real time. So obviously surveillance require real-time detection and recognition, which postures stringent computational and latency constraints. Next is human activity detection is objective visual-based detection, like CCTV cameras, wearable cameras. These are the third, that is visual-based. So where we use deep learning algorithms for recognizing walk, running, gesture from a video. Next is sensor-based. Using this wearable device, like we have the smart watches. They have a lot of sensors in smart watches. They are smart belts. So we have they use the smart belts, and you can do some exercise or something. Maybe you are running or you are walking. That also they will capture how many distance you have captured, what is your speed. Even the GPS is also there. So they will say which path you have tracked. All these things will come for that. Next is audio-based detection. Uses sound signal to detect activities through microphones and other sensors. This is basically used which have like people who have some problem with hearing or saying, say recognizing clap, speaking or other physical interactions. So for there, this audio-based detections are highly used so that they can actually work with based on the audio-based things. Or sometimes let's say we give instruction to the Google Assistant. So there also we give voice, but then they do something. Though it is not a human activity recognition, but I'm saying that is also an audio-based detection, right? Now, supervised learning. So what are the technologies used here? Basically related to activity recognition, not other things. What are the technologies used here in supervised learning? Basically, in the machine learning, we use SVM, random forest, and in deep learning, we use CNN and LSTM. Why? So for machine learning, SVM and random forest, these are for use for classification, but obviously that amount of data should be less. And basically, mainly they are used when the data is sensory data, not the imagery data. When the image data, that means the size will be huge. We normally take it. Then deep learning will come. Deep learning, in the deep learning, CNN or DNN models they are layered based models. They will take and do some classification. LSTM will basically, when you go for videos where the time is there, so it will actually sequential data it will take. So for that, when we have sequence over a sequence or time period, something is happening, then we use LSTM over there to capture over the time. For example, training to recognize walking from sensory data based label as walking and running. So it is just like first one, just like let's say SVM will also work. If it's a walking or running, that simple SVM or random for is sufficient to recognize it. Unsupervised learning involve discovering patterns or cluster of data without label. Example, this is useful for pattern. Okay? For example, identifying new types of movement patterns that are not predefined. Let's say new defined and this is unlabeled. Someone is doing something. So it will say it's unlabeled. It is no label is found, and these are the features. So now, if you want to label it, you label it, or it will always I will keep it as unlabeled data. Another thing is semi-supervised. Now, it is not always possible to label that 10 lakhs of data, and it is also now but the accuracy with unsupervised is very less. So what people say, like there are techniques called one-shot learning or n-shot learning. They said that few of the data we will actually label and rest will not do, and we use some combination of label and unlabeled data and get a good accuracy, though decreasing the hectic of labeling entire data. Though they are not much popular, but yes, there are algorithms on it. Next is sensor based. So this is video based. So basically supervised, where we are taking the data from the video. Now sensor based. So focus on sensor based activity recognition, like as I say, smart fitness trackers, smart watch, smart glasses. Okay, they have lot of sensors like accelerometer, gyroscope, magnetometers, and lot others, proximity and movement for a lot of other things. So you have Fitbit, Apple Watch. I think Samsung also have some watch kind of thing. So the wearable, the sensor, they have lot of sensors. The sensors will collect the data based on your movements. Multi data fusion, multimodal data fusion, because the data maybe the gyroscope data and the accelerometer data, they are values, but the GPS has latitude and longitude. So they will do a multimodal, means different type of data. Modal means different type of data, not as all the numbers. They have different types. So that's why they are saying multimodal data fusion. So GPS data is latitude, longitude, whereas the accelerometer data may be numbers. So they will accumulate all this type of data and finally do some classification on it. Allows for more accurate activity detection by capturing a comprehensive view of the human motion. Common activities recognized: walking, running, sitting, standing, lying down, and more complex gesture like waving or jumping. So smartwatch detects walking or running based on the movement patterns from the accelerometer and gyroscope sensor. These are very common. Like even I think 5 years back also the smartwatch also have accelerometer and gyro. Obviously smartphones have, that we always have, but the smartwatch also have. Now video based, obviously computer vision come because we have the camera based. So deep, as I already told this, so deep learning models. So CNN based models means DNN based models. They are layered models. So there we do classifications. If they are recurrent models, recurrent neural network, that means it has some time component over the time. So if it is over the time, then we will go for recurrent neural network. But if it's only based on the video it's given, it's not changing over the time. One piece activity is one piece. Okay, it is doing this thing. It's not always like same activity is not changing over the time in a different way. Then it will do it in a CNN or DNN model. But if the same activity is changing over the time, different time, then we have to do the recurrent neural network. Now object tracking. So detecting and tracking human figures over the time helps in understanding the complex movement like walking or doing something. Action recognition, again, that will analyze the spatio-temporal changes over the spatial data as well as the temporal data. Temporal means over the time. These systems need to handle changes like lighting variations, occlusions, and diverse background. So CCV systems can track and recognize activities such as walking and running and suspicious behavior using AI. So in airport, it is highly used. And not only airport, nowadays in many places, these are highly used. So challenges is complex in motion. Human motions perform a wide range of activities that involve intricate motions, often involving fine-grained details like small gestures, like someone is smiling. So he has taken his hand while smiling. He has taken his hand on the face, and someone was crying. He has taken his hand. Someone is coughing. He's taken his hand in the face. So it's very difficult to say he's crying, he's smiling, or he's actually about to cough, because all the time he has taken the hand before his face. So there are small things, but obviously then we have to look for the eyes, we have to look for the context, all the things we have to look for it. Occlusion and interaction. As I said, this is, again, taking the hand is basically an occlusion. So if there is occlusion, then what we have to do? Obviously, we have to see the context of that. Next, lighting and background variation. This is always there. This problem is always there whenever there is a camera-based classification. What type of angle is there? Camera angle. What type of light is there? What type is the background is very noisy? It's like thousands of people is there, and you are detecting one people out of that. Then obviously it will get distracted. Which people you have to take? So these distractions are always there. Long-term temporal relation. If the activity is very long, our model can, let's say activity is going on for 5 minutes. Is it possible to understand that it is actually what activity it is? Maybe smaller activities can be okay. It will analyze the context and get it. But if same one activity which started from time 0 to time 5, from time 5 it's complete, and then only you can understand. It is really, really difficult because it takes a lot of data and lot of understanding. Like a person running to catch a bus. So if the example is person running to catch a bus, if he is running to catch a bus, whether it's running or catching a bus, because he can run for a long time. So it's really difficult at that time when if the relationships are very, very long. So activity recognition in busy airport with walking, sitting, interacting poses, challenges due to occlusion and background, dynamic backgrounds. Now key algorithms, HMM models. These are older models, but still nowadays highly used in sensory-based data. So popular recognizing sequential activities based on the time in the time series data. HMM models, HMM can model the probabilities of different human states over time, like walking, sitting, standing. So in sensory-based data, HMM models are still widely used. CNN models are widely used in images and the videos. So based on using recognizing patterns in image data. CNN helps in detecting poses, objects, and actions in the video. RNN are a variant of capturing long-range dependencies, crucial for recognizing activities that involve long-range pattern, such as walking or running over the time. Next is KNN, so a simplest yet method for recognizing activity based on the proximity in the data space. That is called the context. So we use, along with the CNN, we use KNN to get the context. So KNN does not come alone. It normally goes with some of the above models. Okay, so that we can capture the context along with actually doing the classification. Now, advanced technique, transfer learning. So transfer learning is pre-trained models from large. Let's say our data set is very small. We tried a lot, but we cannot get it. Still, then what will learn? Then the model will overfit. Then the technology comes is called the transfer learning. If your data is smaller and you tried but you cannot get it, then go for a transfer learning mechanism. There are many transfer learning mechanisms. This is just a definition, but there are 5-6 mechanisms for doing transfer learning. So overall, it says that pre-trained models from large data sets are fine-tuned for human activity recognition, reducing the need for extensive data levels. We have already pre-trained models for some other things, for other models, for other data. We take the feature vectors from there and train in our smaller data. And how we will train it? They have 4 or 5 techniques for it. So this is one of the very powerful way to use that can be used in the smaller data. So transfer learning is really a powerful technique. Attention mechanism. Attention mechanism is if we focus on entire image, it might happen that we get distracted. So we should give attention to the maybe person face, because person face is always important, or person hands for our activity. So we should focus on some places or something, right? So we'll give attention to something. So this technique allows the model to focus on the most important part of the data, which is most important. So we'll focus on that, and so that the final classification will get biased to the attention towards. Because if entire image, there may be 4 people, chairs, tables, and everything is there, it may get distracted. So we give attention on the particular human and its gestures. So then because we are doing activity recognition, so there are different attention mechanisms, not a single attention mechanism. There are different attention mechanisms. These are generic, I'm saying, but the attention is very, very important when especially if it is the image based. Now, generative models, when data is less, we use, or there are noises in the data, we use synthetic data. So generative adversarial networks or deep learning models to generate synthetic data for training. So especially used when the label data is scarce. That means the less, or maybe imbalance. There's one or two classes are very, very scarce and others have a lot of data. So for them, we use some generative model, generative AI, so that we can use some, generate some synthetic data for it. 3D CNNs are basically above the 2D CNNs. Okay, so that where that spatiotemporal data can be captured together. What will happen earlier is we use 2D CNN with LSTM to make a 3D CNN. Now, not now, I mean saying, let's say maybe another 10 years back, the 3D CNN itself has come. The only CNN can also do the 3D CNN can do the part of work that LSTM do. Okay, so that it can also capture the long-term relationships also. Okay, not everything, but yes, to a wide range, 3D CNN can do what the LSTM does in the activity recognition. So using pre-trained deep learning models for action recognition is limited dataset, improving model accuracy in new environments. Stepwise data acquisition, I already said, video cameras, wearable sensors, RFID and motion sensors, and depth sensors. Next is feature extraction, time domain features, frequency domain features, key poses, and motion features. All I have already described it. Okay, how whatever features. So time domain features, maybe standard deviation, skewness. These are if they are sensory data. Frequency domain features, whatever transform we can use. Pose estimations we can use. What type of motions we have, all joint motions. All this we can use from the. If you have sensor base, they will extract it from the motion sensors. Next is modeling techniques. Whatever technique you use. So traditional machine learning techniques, they have SBM, KNN, and random forest. All these are traditional machine learning techniques. If it is a data set is used, then we can go for CNN, RNN, or 3D CNNs, we can go. Apart of that, if you have to go for a complex network, recently the most popular is transformer networks. Recently, transformer network has become exploited for long-term dependencies in activity data, especially for sequential data recognition. So it is now the popular is the transformer network with attention models. Finally, is temporal modeling, because as activity, that activity is not an image. In an image, you cannot say it is someone is standing or someone is sitting, you cannot say. Maybe someone is going to sit, obviously that is sitting. So obviously we know we need the temporal modeling. So basically in the sensory data, we use HMM models. In image data, in video data, we use LSTM or 3D CNN. I already described that thing. Finally, is evaluation metrics. So their accuracy. First is how much accurate detection has been done. Next is for detailed parameters, we have precision, recall, and F1 score. Those who will do programming on it, they used to have to, apart of accuracy, they have to go for precision, recall, and F1 score also. And finally, is confusion metrics. These are the metrics, standard metrics, which are used for activity recognition. So where we can use in the real time, like edge processing, stream data processing. So edge processing is basically performing recognition at the source data collection rather than relying on the centralized server that reduces the latency and ensures faster processing. Edge data processing means we use data processing, some processing in the mobile phones, some processing in the servers, so that there should be some privacy prevail. There should be some privacy, as well as data processing will take lesser time. So we should not rely on the centralized server always. Streaming data, so this real-time data, so this continuous data will come. So how to accommodate the continuous data over the time without delay, and result should become. In the smart environment like smart homes, wearable technologies, urban environments, nowadays smart hospitals, smart airports, smart city, smart homes, these are very popular. So when they will say smartness, that means there should be a lot of AI will be used here. And obviously the AI where the AI will be used, that means the cameras and sensors have been integrated. And the cameras and sensors are integrated, that means they are taking some images and data and doing something on it. So whether they are the motion cameras, they are the normal cameras, they are the voice assistant, whatever it is, or they are the tracking sensors, or they are the proximity sensors, or they are temperature sensors, whatever they are finally doing, they are taking all the data and making some smart decisions out of it. Some ethical issues are always there because their cameras are involved. So privacy, data sensitivity, fairness, all these are so like if you're taking the face of some people, you should have taken some informed consent from them. And how will that disclosing their face will not be involved in some issues. All these concerns are always there when the cameras, especially if the cameras are involved. So basically, it is using suspicious activity detection, crowd analysis, anomaly detection. Suspicious activity is mainly used in like places like, as I said, in airports and when the surveillance is crowd. Like there is a whenever there is some festivals, there is a crowd, and there may be a stampede and everything happens. So obviously, in that case, if we can understand that the stampede going to be happen, we can take some safety measures. And anomaly detection like theft or something is there like abusing someone or thefting, this type of unusual behaviors is happen. If we detect it we can detect them using the activity detection. So these are the future accountability. You can see it like these are just in the future. These are the future directions: multimodal activity recognition, real-time feedback, personalization, explainability and transparency, ethical AI. Nowadays, ethical AI is very popular. A lot of people are working on it. Before first 3 points, already a lot of work has been done. Integration in IoT and edge companies is in progress. People are already worked and people are working. And ethical AI has because nowadays people are concerned that how you can disclose my face or disclose this thing, disclose my data. So ethical AI is nowadays quite in good news, in the good in the news in the market that people are working on it. So these are the related publications. Though in my website there are a lot of other publications are given. These are the related publications in the activity recognition. Okay, any questions? So what we will do is I will take the questions after in the second session. For these questions also we will take in the second session. Because already I have taken half an hour extra almost. So I will take the maybe in another 5 minutes break or 10 minutes break I will start. And I will take the questions for this session questions also in the second session. Will it fine?
Yes, ma'am.
Okay, so the next session I will make it shorter. In the initial part I will make it shorter. Okay, so let me start in, let's say 35. It's 27 now. No, sorry, it's in Indian time. It is
At 4 o'clock.
It's 3:58 now. So we'll start at 4:05. Okay.
Yes, ma'am.
Yes, ma'am, 4:30.
We'll start at 4:05. So there's a 10 minutes break, but I'm shorting it to 7 minutes break. Okay. Within the two sessions, there's 10 minutes break, but I'm shorting it to 7 minutes now because we are running out of time. So so that I can complete in the right time. Okay, so let us start with the second session. So what we'll do is we will quickly describe the just AI/ML part for transportation, not the definitions anymore, because the definitions will mostly be similar. And then we'll come to the question answer session for both the sessions, because we have only 1 hour. So maybe in 40 minutes, I will cover the AI/ML relevant to transportation only, not the definition of AI/ML anymore. And what are the topics has not already been discussed, like RL, that part I will cover. And then I will start to discuss with the question answer sessions. And if you want, I have already actually I have put taken 2 papers also, but I don't think it's running out of time already. So I don't think I will get time for the research papers. But anyway, if anyone is interested, I can also go for that. And just I want to say that if in case you are interested to know, like you can. So this is my homepage where we have the publications are there actually. So if anyone in the like in future interested to work in this direction, so maybe any of the paper you want to extend it in your future if you have interest. It's not like just one domain. There are a lot of domains. Like artificial intelligence is huge thing, right? It's a lot of articles it have. So there are transportation is there, audio is there, computer vision is there, text detection is there, a lot of other things are there. Okay, so anyone if interested to work in these directions to extend my work, maybe we can discuss in the future. So now let's start with the presentation. So I'm skipping this part, the what is AI and all this part. So we'll coming directly to the. I'm audible, right, to everyone?
Yes, ma'am.
Okay. So so what are the changes are there? Like here we say the key focus area is traffic management, autonomous vehicle, route optimization, and real-time navigation. There we have given some different examples. Here I have taken mainly this type of key focus area where AI is used in the transportation. So in transportation navigation, basically leveraging the machine learning and computation and NL. So here 3 things comes: machine learning, CV, computer vision, language, natural language processing. Because obviously we have to process a lot of languages here, and robotics to improve the efficiency, safety, and reliability in transport system. So these are the similar things. We are not going for them anymore. So where the AI can be used, like in traffic management, so traffic prediction. So use the historical data to predict the congestion patterns, adaptive traffic signals. So for how the traffic flow will be, like whether there will be a jam or not, whether what are the peak hours, what are non-peak hours. Incident detections, like if there is some accident or not. Road usage, what is help the city planner to optimize the road infrastructures, what is the quality of the road, this type of things. Now in autonomous vehicles, obviously autonomous vehicles, the name itself says that it is full of AI. Okay, so perception of sensors and cameras in detection of object, pedestrian vehicles, path planning, decision making whether to take a turn or not take a turn, whether it's a loop or not loop. Okay, like Tesla autopilot, there are some vehicles have come. So these are the on test of in some countries they are using also, but they are mostly on test actually. They're not in. I don't think I have heard that they are in selling condition. They are in test. What I know, I think no. Next is obviously route optimization and navigation system. This is used by the Google itself. So dynamic route optimization. The real-time traffic data helps to AI to reroute vehicles to minimize travel time. In the places like metropolitan cities and something, there even if there is a one way or two way, and though it is actually not one way or two way, but that time it's made one way or two way, and that data has been uploaded by the traffic authority in their web page, then that also been included by Google. I have seen. So for the time being, due to congestion or due to some VIP activity, they have made that this data is one way. That if this traffic authority they have uploaded in their website, that also Google also take care of that also while predicting the things. Then predictive analytics, like AI anticipates traffic surge based on the historical patterns that we always know. Integration of IoT connecting traffic lights, sensors like pressure sensors in the road, so to have the number of count of vehicle count, okay, vehicle pattern, speed, all the speed, over speed, non-over speed, all this data can be covered. Not only camera data, all this can also be covered from sensor. Many of the roads, like in many of the places in the road itself, there are the sensors has been grounded, so that when the vehicle will pass over the sensors, the speed will be automatically calculated, or how many vehicles has passed from this to this time. All this not for the cameras. Cameras mainly used for detecting the number plate. The number plate cannot be detected by the sensors. Obviously, the speed and also can be detected by lidar cameras and all this thing, but the sensors are more perfect in this case. But again, if you say the number plate, then there's no option. We have to go for cameras. Like Google Maps using crowdsourced data. So Google Map not only take the data from the satellite, it also take crowdsourced. If someone is tagging it's a busy area, continuously run into also the many GPS locations has been GPS are on at the same time in the same area, and people are also maybe tagging some event is going on kind of thing. They also take care of them to get the final prediction. Logistic and supply management. Those who are working in the transportation domain or similar domain, it will be very useful because this is very focused on transportation only. This presentation is very focused. So, AI application in freight and logistic, like load optimization. The trucks are overloaded and not overloaded. Maybe the revenue collected from them should be equal, or even though how much they're overloaded. So this revenue collection is a very big matter actually. How much should be revenue collected? So load optimization ensure the efficient space utilization in trucks and ships. So let's say how much not only the load, not only the overload, non-overload. If you take a rectangular boxes and you take round boxes, in the same square box, the number of rectangle boxes will come more obviously than the round boxes. So that is also called space management. So these type of things are also matters. Predictive maintenance. So AI predicts vehicle or equipment failures before they occur. So the insurance companies are very much interested on this part, because if already your vehicle has been failed or done something, then lot of amount they have to pay. And if before that he has come to know that it is in a condition where it can be failed in near future, obviously the insurance payments and will be different. So the insurance companies are very much worried for this. Consider this part as very seriously. Now, real-time tracking. Obviously, nowadays we always use Google Maps. Okay, so real-time, where we do the real-time tracking. AI integrate GPS and RFID data for accurate shipping trackings. For like we know that like in many cases we have I don't know, means in international trackings also they have this RFID tags, and they said that from tracking that it is on a ship, it will go show you updates based on the GPS and the RFIDs which are attached with the shipments. So Amazon using AI for warehouse automation and delivery planning. So they have every box, they have the GPS and RFID tags over there, so that they can track exactly this moment where the packages are. Because they have huge money involved in this. So they do for us, maybe we'll not do it, but the business people, they used to do this because there are huge maybe money involved in them. Now AI powered public transport system. So where the AI is used, scheduling optimization. AI predicts peak usage time and adjusts bus or train schedules. So if it's the peak hours and there is a lot of congestion, they can reroute the buses, or they can delay some buses, and maybe after that they can adjust those buses at that time. Passenger behavior analysis identifies the passenger pattern to improve service delivery. So how the passengers are behaving, what the necessity for them, are they mostly looking for this route A buses, or less people looking for route B buses. So based on their behavior, based on their requirement, we can reroute the things. Safety enhancement. AI system monitor driver behavior and vehicle conditions. So a lot of places nowadays the drivers driving type monitoring used to be done. Nowadays most of the vehicles, new vehicles and which are high-end vehicles, they have the AI system to check the how many times the car has jumped badly, how many bumps it has gone smoothly and it has gone badly. So this type of analysis data it automatically take and send in the servers, so that because this type of things like Ola and Uber and all these things, they actually want to track their drivers. They are rush drivers, or they are really rush drivers, or someone has the people have given intentionally bad feedback. And if they are rush drivers, obviously they will not given the track, because that is actually they are defaming the company itself. So nowadays, this type of tracking devices are very highly used by these transportation companies. Then smart ticketing system, AI ensures seamless payment and personalized travel plans. That we always know. We have different websites that we can do the personalized travel plans. Now, challenges for implementing AI in transportation. Data privacy concern. Obviously, when we have this type of things, when we use AI, that means we are taking data from other people. And if you're taking data from other people, we have to see what is the privacy concerns. Whether we can actually share their data, whether their name or ID is there. If the name or ID is not there, that data also is they allowed to share. So every time you can see when you install an app, any app, they will ask from privacy issues, that they will use your data from your mobile, they will use some of your pictures from your so most of the time we Indians, mostly I'm saying, okay, maybe there are people who are really cautious, we don't read it, we just said we accept it all, but actually that is not good. There are options that you can selectively choose also, but very less people actually selectively choose. They always say okay all and just stay, and your data all of your data actually are going to the server, whatever you are doing with the smartphones or the apps. Okay, so but many countries are very careful about this. So that's why in the few years back it was there in the news. Now Facebook has been banned in many of the countries because they are selling all the data of this. All this news are there, and they say no, you cannot give all the data of our people. So privacy concerns are in some countries are very really they take care of this thing. The infrastructure requirement, high investment needed for smart infrastructures, but though we are actually looking for smart bridges, smart roads, smart cities, that are very much concerned nowadays. Algorithm bias, AM system may inherit bias present in the training data. So we have to see that the data should not get biased. That is always there for any AI, not only in transportation. When we come for algorithm, we have to see the data should not be biased. Regulatory hurdles like compliance with safety and ethical guidelines, we have to always take care of. Especially nowadays, nowadays the UAVs we cannot fly UAVs in the public places where the faces of the people will come without consent, without their taking their proper consent. So, but in many countries it is actually allowed. So these are the privacy and safety issues, ethical issues are there, and they are different from different countries, and that we have to take care. So in AI, if you say AI in transportation, what are the technologies used? Is machine learning, computer vision. Computer vision means that the data come from cameras and sensors. NLP, that's a natural language processing, that is speech or voice-based system. Reinforcement learning, that is a new thing. So I will discuss. I will leave first three, and I will directly come to the reinforcement learning, because that is a new thing that is present here. So model that optimize real-time decision making based on some actions has been happened. So adaptive traffic signal. So I will come to this in details later on. Metrics that are used are accuracy, latency, scalability, reliability. Accuracy is obviously how much correctness is this. Whatever you are doing, whatever prediction, detection, classification, whatever you do, how much correct it is. Latency. In real-time application, if it is an autonomous vehicle, let's say it's an autonomous vehicle or a UAV, unmanned vehicle, obviously that means the decision has to be taken instantly, even within few seconds, not within few minutes. You have to take a turn, that means you have to take a turn. So that means that it should be, the response time should be very fast. So it matters a lot in transportation. Scalability, obviously day by day the data is increasing, day by day vehicles are increasing, day by day the use of UAVs are increasing. So the data the algorithms you're using should be scalable to large amount of data. Reliability, consistent and performance under different conditions. Sensor data or camera data or any other data, whatever data you are taking, it should be able to distinguish between the inlayers and outliers. Outliers means noises. Inlayers means the useful data. It can actually distinguish between them. That is called reliability. And it should be equipped with the different weather conditions, different angle conditions, different other noises may happen. All these things they should accommodate. Obviously, 100% is not possible. It's never possible 100%. But at least to some extent, it should have. So again, I am skipping the definitions of machine learning. If you have any doubt, you can stop me there. Okay. I'm just skipping because I've already discussed this part, so I'm just skipping this now. So I will just want to describe a bit of ridge and lasso regression because that time I have described in very small and very short actually. So ridge and lasso regression are both regularization techniques used in linear regression to prevent overfitting and improve model generalization. So basically, those who have done a bit of machine learning, they know that there's a very big issue with the overfitting of the models. So there we have to use some regulation technique so that this overfitting can be handled. So like we have to add some penalty in the cost function so that the overfitting does not happen. Overfitting happens when the data has some noise and that noise cannot be properly handled or the data is not sufficient to get with the model. So what ridge regression does is, which is called L2 regularization, adds a penalty term proportional to the square of the coefficients. What are the coefficients have in the linear function, in the linear cost function? Based on that, the square of the cost function, they will add some penalty. This helps reduce the magnitude of the coefficients, thus preventing the model from fitting too closely to the training data and reducing overfitting. That means it should not be biased to the training data. It should not be highly biased. If it gets highly biased, what happens? A data, unseen data, which are a bit different, you cannot take it. So that's why it adds a penalty in the cost function. For example, predicting the house prices with multiple features like square foot and number of rooms, where ridge regression prevents overfitting by shrinking the larger coefficient. This example I already have discussed last time also. Now, lasso regression, in short called least absolute shrinkage and selection operator, or L1 regularization, adds the penalty term proportion to the absolute value of the coefficient. Earlier was square of the coefficient, it was absolute value of the coefficient. Unlike ridge, lasso can shrink some coefficients to exactly 0, effectively selecting a subset of features and performing feature selection in addition to the regularization. So obviously it is actually decreasing the features, though it is removing the unnecessary features. So obviously it is normally better. If the feature set is very big, it is better. If the feature is small, then ridge is better. Now, application of regression in transportation. So travel time prediction. Regression is widely used to predict travel time for different routes based on the factor like distance, time of day, weather conditions that we always use in Google Maps. Okay, so predicting arrival time of the public transport vehicles on current location and expected speed. Fuel consumption. Use case regression models predict fuel consumption based on the variables such as speed, route, type, and vehicle load. So these, though we as a personal vehicle, we know not much, but the freight, which are the like the trucks, the freight vehicles, they have a lot of effect on this because they have to calculate how much they are paying for the travel costs also. Using linear or polynomial regression to estimate the fuel required for a trip based on the distance and driving patterns. Next is price prediction in ride sharing, like share autos, Ola share cabs, and some in between I have heard some sharing bikes also. So how this price can be predicted? How can be done? The use case is regression is used to predict ride prices based on the variables such as distance, demand, and traffic conditions. So dynamic pricing in ride-sharing services like Uber or Lyft or Ola, where regression models predict the price of a trip in real time, adjusting for factors like traffic and or weather. So distance we know because they're going from this to this, but if there's traffic, there's a waiting time, or there's some weather effects are there, then how they will be estimated. So that should actually add to the cost, and it is not a single person that finally the cost will be calculated. People are coming and going, so that time also in real time, the person who is going off the auto or off the cab should actually pay for it. Not the final last person should pay all this extra cost. So that in real time, real price should be predicted. Demand forecasting for transport services. Predicting demand for transport services, bus or taxis at different times and location to optimize resource allocation. As I said, like most of the people, let's say in working hours, want to going by the route A, not by the route B. So obviously we have to have more buses at that time, and the road condition will also be good so that they can accommodate all the buses. So that way you can optimize the resources, and there are empty buses are running in the road in the office hours. Obviously they should be decreases because they are wastage of money in the fuel. So this type of things we should do. Using regression to forecast the number of passengers at different bus stops based on hierarchical data and external factors like holidays and or weather, we can do this thing. Now, price prediction. Okay. Now, next is so I will again skipping the classification part because we have already discussed. So I'll come to the example like congestion detection, classifying. So we know what is classification, like it will be categorized the input into different categories, right? Not like regression. So classifying traffic conditions into categories like low congestion, moderate congestion, high congestion. So these can be three classes or three labels, and we can classify them. Or road condition classification, like classifying road based on the sensor data categories such as cleared, icy, or under construction. This type of classes we can make. If, for example, using images from traffic cameras to classify roads condition or detect accidents. So accident, non-accident. This can also be a type. These two can also be a classes. So this is also I'm skipping. I have already discussed it. If you have a doubt, just raise your hand and just ask me. In the slide that I'm skipping. So linear models. Linear regression, logistic regression, tree-based, random forest, gradient boost trees, deep learning models, neural networks. For regression and classification, instant-based, KNN, and the closest neighbor-based, all the algorithms are instant-based. I have discussed them already. Now, real-time application for supervised learning in transportation, where actually in real time they are used, not the data can be used afterwards. Dynamic route optimization, I already discussed this thing, that the Google Map, what the Google Map does is kind of dynamic, not 100%, but a kind of dynamic route optimization, predicting and adapting travel routes on real time, based on the condition of the road, based on the condition of weather and all this thing. Vehicle health monitoring, predicting failures or maintenance need require regression models for historical sensory data. Driver behavior analysis, classifying the driver pattern. If driver is riding recklessly, maybe some alarm should be gone to the authority so that the passenger should not be in false condition. Use cases predicting arrival times of public transport using supervised learning trained on the past GPS data. Now challenges, data quality. Obviously, whenever we say that everything we are learning through data in any application, that means data quality matters. Require large labeled data because it's supervised learning and which is expensive, difficult to obtain. Overfitting. The models may perform well on training data but fails on unseen data. Next is identifying the most relevant features, feature training. So we have to do proper feature training. Computational cost. If the huge amount of data is there, then we have to, in real time, we have to process it and get the results. That means the high-end processors should be there in the servers. Dynamic environment. The environment changes more. It's not like a static things. In the transportation, the dynamic environment are very, very randoms. So we cannot say all, if it is a junction of 4 or 6 lanes or 4 or 6 passes together, then all the conditions we cannot actually train the system. So there obviously there are a lot of new pictures will come. It is obvious there. Yes.
Hello, ma'am. Am I audible now?
Yeah.
Yeah, ma'am. Good evening, ma'am. Actually, ma'am, I could not attend your previous session. Actually, ma'am, I want to know in case of transportation, what elements or what matrices to be focused on this regarding.
I will come to the matrices. Later on, they are there. Okay.
Okay.
Like last session, also the matrices are there in the end.
Okay. Thank you.
Okay. Yeah. So computational cost, dynamic environments, because in transportation dynamic environment is very challenging, and we cannot never say that this if I even take 10 lakhs of images also of our six cross.
Ma'am, sorry to interrupt. Actually, suppose the cost of transportation needs to be determined, then please, after this session, when you go through detailing, then please give an example, ma'am, how to find out the cost, ma'am, in case of transportation.
So it depends, it depends. What are the factors you are taking? It depends. What are the factors? What their traffic, the traffic authority? What are the factors they are taking? I cannot decide it. What I can say some examples. I can this can maybe, but what depends country to country, place to place. How much they are using the data, whatever sensor they are in that place. If it's a metropolitan city, the cars are very high. Normally they're not taking 10 years old cars. So now the new cars have a lot of sensors. But then the cities which are not that metropolitan city, they are using still old cars. They don't have much sensors. So obviously the cars or the vehicles, they have less sensors. They will give less data. So it depends actually. We cannot say that this will happen. Okay, so let me say,
ma'am, please, which model will be best fit? How can we find out this kind of model is going to be fit to train and test the data?
Yeah, the same answer actually I given in the last session. As you said, you have not attended.
Okay.
Any programmer has to see the data and have to. There are the few concerns. I will again come after the. Let me complete it because I'm running in time. I will repeat it again. Okay.
Thank you, ma'am.
I have given this answer in the last slide actually, in the last presentation.
Yes, ma'am. Please.
Okay, so the matrices that are used for supervised learning is regression matrices like mean square error, that is used for regression. So measuring the average square differences between the predicted and actual values, and R squared, explaining the proportion of variance captured by the model. And for classification, last time the matrices that I said, the same matrices will come: accuracy, precision and recall, and F1 score. So regression for mean square error and R square error, these are the popular matrices that are used for supervised learning in the transport. Now, advantage, obviously accurate prediction because it's a supervised learning, real-time decision making, improved safety and efficiency gain. Now we come to unsupervised. Now I already discussed this, what is unsupervised learning. I'll just come to the example. So traffic flow patterns, identify clusters of traffic behavior to predict congestion hotspot or traffic bottlenecks at specific times of locations. So last time I said that how the clusters will be there. So this way, if there's a congestion, we can say this is a cluster. This can be a cluster head, and it can be a cluster. Or there's a bottleneck, traffic bottleneck, that can be a cluster, and other such parts. So we can use unsupervised learning also, like K-means or something like that, DB scan for them also. Travel driven segmentation, grouping passengers or vehicles based on the sheer characteristics like routes, travels, and common destinations. So here in this type of scenarios, we can use unsupervised. Though unsupervised obviously does not give as good result as supervised, but still there are possibly, like in action recognition, we have less possibility of unsupervised, but in here we have a higher possibility of unsupervised learning. So I am not skipping this part again because we have described it earlier. Now, if you need any questions, you want to ask me. Now we come to dimensional reduction, the new thing that is added for unsupervised learning in transportation. So in transportation, the data are there are a lot of data actually, because a lot of vehicles entire day are going, coming, and they have a lot of things like distance, they have health, health, they have routes, they have the signals, and GPS locations, their transportation routes, tracking routes, vehicle counts, load of the flights, their how compact they are, what is the overload and underload, all these things, the lot of data at a time. So there's only not few classes. So data is huge. So dimension reduction of the data is very, very essential. So here, that's why in unsupervised learning, there is a part called dimension reduction that I have not discussed last time because it was not important in terms of activity recognition. But here is important. So dimension reduction technique are used to reduce number of features in the data while preserving such as much information as possible. It will reduce the dimension, keeping the important features and reducing making the unimportant features to zero, so that the dimension get reduced and it will actually give output in real time, because in the transportation, real time outputs are highly required. In particular, useful in cases where the data has many features that can be correlated or redundant, thus improving computational efficiency and model performance. Because real-time data, that means you have to do faster. Within seconds, we need it. So if it is a very huge feature vector, then it is really not possible to give results in few seconds. So we have to choose whom we should keep and whom we should remove. And that we'll do. So like earlier, it's only pre-processing. Here, after pre-processing, dimension reductions come. After the pre-processing state, if you remember, I said the capturing data, then pre-processing, then modeling will come. So in between, there is a dimension reduction will come. So application is visualization of traffic data, reducing the high dimensional traffic data like speed, traffic, volume, weather, time of the day, a lot of other things like vehicle health and other things will come to the lower dimension, making it easier to visualize and analyze the pattern, reducing the complexity in model by reducing the number of features. Dimension reduction helps in building a more efficient machine learning model for real-time traffic prediction. So here the important here is real-time traffic. Earlier it was important is to make it easy to visualize and understand the patterns of which are required, and which maybe for one place the time of the day is important. For other place the speed is important. So we cannot say the same dimension reduction will be always applicable for everywhere in every road. No, it is not there. Maybe in one toll plaza there is in highway there is the different pattern is following, and other toll plaza in that roadways there is a different pattern is followed. So obviously, based on the data and based on the things, we have to see what type of dimension reduction will be done. Now, what are technique for dimension reduction is PCA, principal component analysis, or T-distributed stochastic neighbor embedding. These are the very popular. Though there are many more methods, but these are very popular. PCA is also used in computer vision, principal component analysis. So basically, PCA transforms the data into new coordinate systems, such as the greatest variance of the data comes to a lie on the first coordinate. So you just read it from because PCA cannot be described in a single line. It is a mathematical equation. So PCA and the TSNE actually these are highly used for the data dimension reduction. These are both they have equations, and they're very PCA is very old. Maybe 30 years back also PCA was there. I think so. And TSNE is also not a new one, because it was very good for non-linear dimension reduction, not linear dimension. It works nowadays. It's very highly used actually. Now next is anomaly detection. So if there is lot of data, if there are lot of variance, then must be anomaly. So anomaly detection identifies the unusual or outlier data that do not conform to expected patterns. These outliers can indicate rare events such as accident, equipment failures, or unexpected traffic conditions which require immediate action. Like immediate like some accidents happen, or some congestion has happened, or some rally has come suddenly, and that was not there in last maybe 6 months or 1 year. So what action should be taken? Obviously, so accident detection, detecting sudden traffic shutdown, slowdown or shutdown for changes in traffic patterns that might indicate the accident or road closure. Maintenance alerts. Obviously, the road has been closed due to some maintenance. Maybe some big hole has come or something. Identifying the anomalies in the vehicle performance data that could signal a potential failure, enabling the predictive maintenance of transportation road. So always the traffic, these traffic people, they do not update it that for maintenance this part of the road has been closed. They just put the board and they started, and all vehicles are there saying to reroute it. That means obviously if it is a tracking system, it will not wait for the traffic people to update. If all the vehicles and GPS are rerouting it, that means there is some congestion, there is some issues are there, and they should update the road for that. Isolated forest, like this algorithm isolates anomalies by recursively partitioning the data. It is well suited for high dimensional data with large number of features, like detecting abnormal traffic incident or incident that deviate from typical traffic patterns. Like there are abnormalities which are also not normal. So they are not even if we categorize the abnormalities in some categories, still they does not fall in any category. So that type of, because as I say, in transportation we cannot take all instances. Transportation is not like activity. Still we can say that maybe if we have 1,000 classes, we can still map into maybe 1,000 or 2,000 classes. But in transportation we can never do that. When there are 10 vehicles are together, they have different combinations. So we all even anomalies also we cannot say. So there is always we have to keep the place for something new will come up. One class as SVM, so a variation of SVM that is specified design for anomaly detection in case where data is mostly normal and we are only interested in detecting the anomalies. So we said something different, anomaly, then we will go for other. So that is the first level classification will done by one class classification. It's a normal or abnormal. If abnormal, then we'll see whether any of the already specified is there or not. If not already specified, then what to do. So this type of things are there. So DB scan is also the similar way. It is ability to identify outliers as a point that can belong to the any cluster, do not belong to the any cluster, and make it efficiently for anomaly detection. So all these things except these are new two terms, one class SVM and this isolation forest. These two actually these are the I will say rather improvised version from SVM or from this decision by random forest specifically for this transportation. Now benefits is pattern discovery. Unsupervised learning enables the discovery of hidden patterns and structures in the transportation data, which can lead to better insight and improve decision making. Because in transportation, we cannot do all supervised data. So obviously, we have to go for unsupervised because it's a huge data and there are a lot of randomnesses there. So we cannot account for them. But using unsupervised also, we can discover new type of pattern, new type of feature set, which can be used in future. Scalability. These models can handle vast amount of data, making them ideal for large-scale transportation network and smart cities. Because transportation network is really huge always. There's unending. Like you go by cities, by highways, and then over the states, over the countries, you can accommodate and you can get huge data. No labeling requirement. See, it's unsupervised, so labeling is not required. Improve system efficiency by identifying patterns, clustered and anomalies. Unsupervised learning helps optimize traffic management, resource allocation, or routing, and ultimately leading to a more efficient transportation system. At least it is giving some results. So when it gives some results, we can actually analyze on it. In the first level, it is usual or unusual. So because it is not, the feature vector is completely different from any usual. So this is the first level of once classification is done, then unsupervised classification is done, then we can go for anything else. So that actually reduce the amount of data to be processed in a huge way, and so that we can get the real-time decisions. So reinforcement learning. Now this topic I will discuss a bit. Reinforcement learning is basically till now we have labeled data, non-labeled data. We have some models that work on that train on the data and finally get some output. Here we have let's say this mouse want to get this reward, that this is the cake. But it has a path like this. So what he will do is, to get this reward, he will actually choose some path. If he choose the right path, he will get a reward. He will take a step toward the reward. If he choose a wrong path, he will be punished because he has taken a wrong path and he has gone to the opposite side of the reward of this cake. So this is where basically the reinforcement learning come where we will give some reward or will punish him for the action they have taken, and the real time it will be updated. So reinforcement learning is an area of machine learning where models learn to make decisions through trial and errors. Because he is taking one step and he said that he either get the reward or get the punishment, and based on that he updated himself. And if you go multiple steps, then obviously multiple step he has to come back or maybe take another path. So how many rewards has been how many steps he has taken towards the rewards, or how many taken he has been get the negative points. So that actions will matter actually. So optimizing their actions over a time based on rewards and penalties. So punishment means penalties, and towards the reward means to get something, to get this piece of food. So that adding 100 rewards will reach the food kind of thing. So in RL, an agent learns to make decision. This agent is the mouse. Agent learns to make decision by interacting with the environment. So this is the environment. This whatever the path he have, environment, and receiving feedback. So he is taking, whenever he doing something, he is getting the observations and the rewards every time. Whenever he is doing some actions, he is getting the observations as well as the rewards or the penalties. And based on the next step, he will decide. Receiving feedback through the rewards or penalties to maximize the cultivated rewards. Finally, his goal is to reach the cake. That is the total 100 rewards. But how he will go? So that will be every step he will actually optimize it to maximize the cumulative reward. So this is the reinforcement learning, and based on that, learning will be done. Now, next is the concept is, quickly I will go through the concept is agent, the learner or decision maker, like a robot, autonomous vehicle, or traffic signal controller. Environment, a system of the world in which the agent operates, like road, traffic system, or city structure. Action, the choices of the agent which make each step, where he was taking, accelerating, or turning, or stopping. Let me complete because we are running out of time. So let me complete the slide.
Hello, ma'am. Just one thing. Ma'am, robotics falls into supervised learning, unsupervised, or reinforced learning, ma'am?
Every robotics is a vertical. Okay, so all the three used in robotics. All the three. These are learning technique. Robotics itself is a technique. Is a technology, right? All these are algorithms used in robotics.
Okay.
So let me first finish it, then you can ask. Okay, I will give you time to ask actually.
Thank you.
Then the states. States is everywhere. Every step one is take. He will take a positive. He will reach some. Let's say there are n states. In the state, if we take the base state, then maybe after few step only he will reach the reward. He will get the 100 rewards. If we take compromise state, then maybe he will have to go more. If we go for the worst state, then maybe he have to come back. So states are also there, the current situation of the environment, where he, after taking few steps, where he reach is the current state. For example, current traffic condition, vehicle positions, or the road structure, these can be the states. Rewards a number of a numerical value presenting the feedback given to the agent based on the action taken. Policy, a strategy or a set of rules agent follows to decide on its action based on the current state. From the current state, what should I do? That is the policy. Learning process, so it is a bit difficult. It's more because it's come after supervised, unsupervised, semi-supervised, then it comes. So it is a bit difficult, but it is highly used in transportation. So I have keep this part. The agent continuously interact with the environment, selecting action based on policy and receive rewards or penalties. Over time, the agent improves its decision by making which action lead to the highest cumulative reward. So what I explained already is written there, and that is a continuous learning process, and it will learn, and finally it will get reach the destination by getting the maximum cumulative reward. So where it is used? Traffic signal control. In autonomous vehicle. Now, when you come for autonomous vehicle, lot of things matters. There are a lot of parameters, like not only just there are hundreds of vehicles, there are hundreds of people walking, pedestrians walking, there are traffic signals, there are road congestions, there are road breakers, hundreds of things. So obviously, with what action he has taken should be either penalized or be rewarded. So there RL works a lot in the transportation. So RL models can optimize traffic signal timing to reduce congestion and improve traffic flow. The agent learns to adjust light cycles based on the number of vehicles waiting for the interaction. So here the example is given in the traffic signal is for what should be the time for the traffic signal time. It should nowadays it's always static. Either it's 50 seconds, 30 seconds, like that. It does not matter how many vehicles are there, or the road is empty, or still it will go on. It is saying use some penalty. If the number of vehicles, you have a camera over there, use penalty. That there's no vehicle, then the penalty is added, not the reward. And the penalty is added, then the obviously time will decrease. Similarly, in autonomous vehicle, in self-driving cars, RL helps to optimize vehicle decision like lane change, speed adjustment, or braking based on the surrounding environment. So now autonomous vehicle uses RL to learn when to merge into a faster lane or when to stop for a pedestrian, maximizing safety and travel time. So in autonomous vehicle, RL is hugely used, totally used, truly speaking. Road optimization, RL, if you take RL, then obviously it's much better than even supervised learning. Because again, you are penalizing or you are rewarding. So that will not always give fixed decisions. That will actually, the value that will come will not be fixed. It will be penalized or it will be rewarded. That type of decisions will come. Again, fleet management for logistics. So RL are used in fleet management for optimizing delivery routes. Ideal time, like this pizza deliveries and all these things. Ensuring time deliveries with minimizing fuel usage. Dynamic pricing, all this I have example I've discussed. Now the same examples can be again upgraded with the RL, because when we use RL, because RL is an advanced technology over the supervised and unsupervised learning. So when we use reinforcement learning, that means we are not just predicting something, we are also penalizing or we are rewarding them. So obviously that will give a better result. But again, implementing it in a huge data is to make the rules where based on which the penalizing or the reward should be given. That should be very crucial part. Now some examples, quickly examples we'll see, because we have only 5 minutes left. So then we'll go for the question answer session directly. So traffic flow prediction. Now I'm using how you will use in the traffic. What are the networks, whether DNN networks or CNN networks you will use, so that you will, let's say there is a project called traffic flow prediction. So what you will use? So normally in traffic flow prediction you're using LSTM. So how we will solve it? So I'm just showing that thing. So model is LSTM is a type of recurrent RNN model suited for sequential data, and the traffic flow is a time sequence data, time series data. So we can easily use any RNN models. So widely uses LSTM, process the historical data to predict the future congestion. So what are the features can be traffic volume, speed, weather condition, and the time of the day. Methodology, data pre-processing to remove noise, temporal modeling for traffic pattern, because we are using RNN models, not CNN models. So temporal modeling, and because these data are time series data. Prediction with minimized overfitting through regularization. So we have to use regularization. We have lasso regulation, Rees regularizer, right? We have different regularizers. So we have to penalize so that we can avoid overfitting. And the metrics are mean square error and root mean square errors. These are the metrics can be used for this type. Now vehicle detection using yellow. So vehicle detection, that means we need camera based. So camera based means we can use for CNN model. So YOLO is a CNN model. You will only look once, YOLO. Okay, this is a very famous model, and long back and very famous and very good model actually. So YOLO is a deep neural CNN model, deep neural network model that performs real-time object detection. So you can nowadays you can just get .exe files for the YOLO actually. It was so popular. So what type of vehicle is there? Vehicle detection for smart traffic system and autonomous vehicle. In autonomous vehicle, we have to obviously have to do vehicle detection, right? Whether it's a pedestrian, which is a car, it's a bus, so that you can adjust accordingly. So methodology, input frames, split frames into grid cells and predict the bounding boxes for confidence scores, and output detected vehicles and their location. Advantage, high speed and accuracy, effective in varying lighting conditions. YOLO is very robust to lighting condition and camera angles. And it is very high speed. You can get in testing time, you can get really results in, if the images are good, not very high resolution, you will get results in seconds. So metrics is precision, recall, and IOU. IOU is intersection over union. These are very common metrics. Okay. Now, traffic signal optimization using the RL model. Okay, so that is deep Q learning is a very, very famous RL model. Okay, so that's the even in fact the basic model actually for RL. So you can use traffic signal optimization by with that so DQ model. What DQN model learns optimal actions by interacting with the environment. Adaptive traffic signal control to minimize congestion. So we will adaptively control the traffic to minimize the congestion, because if the road is empty, will give less time to the traffic control. Traffic signals. Rather, the road is congestion, will give more time so that the things will be properly done. Methodology state, traffic density at intersection, that in the state. So we have to describe what is state, what is action, what is reward. Then only we can go for the modeling. So these 3 points have been first discussed. What is state? The traffic density at the intersections, at these junctions. Then action, adjust traffic signal timing. So that timing, light timing, we can adjust. That is the action. That action should be performed. Reward, reduction in vehicle waiting time. What will the reward will be? The vehicle waiting time will be reduced. Obviously, the penalty will be opposite. That will be that the vehicle waiting time will be increased. Use CNN to process camera feed and make real-time decisions. So performance evaluation, average delay per vehicle. This can be the one of the metric. Another is total vehicle throughput. Total throughput of the entire network, entered that junction, and the per vehicle delay. Route optimization using genetic algorithms. You have read, you people have heard it in the AI, right? They're very, very old, but still they are used, right? So let's say route optimization using genetic algorithm. You can use in other, you can use regressions also, but let's say use genetic algorithms. So genetic algorithm is a meta-heuristic optimization. See, it is meta-heuristic. It is not a supervised or unsupervised. It's a meta-heuristic. Heuristic means we are trying hit and trial method. So it is meta-heuristic, not completely hit and trial, but meta-heuristic algorithm inspired by natural selection. So application is solving the traveling salesman problem. TSP problem is a very, very popular problem in algorithm in computer science. So everyone did it. So that's the TSP traveler salesman problem is a popular problem. That problem is normally used for route selection of the routes. So they are saying let's solve that problem using genetic algorithm, using vehicle route problem. So what you have to do is initial population of the routes is generated. Fitness function, what is the type of the road? Fitness function evaluate the distance and or time. Genetic operators, mutations or crossovers move the population. Best route emerges after the iterative evaluation. So what is the advantage? Handles complex, large scale problem efficiency, adaptive to various constraints. Evaluation matrix, total travel cost and route feasibility. So these are in this way, even using the older algorithm, genetic algorithms also, we can do route optimization. Obviously, we can do better. So we have already seen many examples on route optimization earlier also. Accident prediction using random forest. So we can use some DNN models also, but we can also do, if the data is sparse, we can use also random forest. So random forest is the example method combining simple decision trees, combining multiple decision trees. So application is predict likelihood of accidents based on road, weather, or traffic conditions. So random forest is a supervised machine learning algorithm, not DNN algorithm, that will make decision, that will based on the decision tree, they will take the multiple decision tree, they will take the decisions. What is it? What has happened? Whether there is an accident or not accident. Methodology, data pre-processing as usual. Then data model training with accident history with labels because it is supervised. Then output risks scores for specific road segments. What are the output scores? Risk scores for specific road segment. Advantage, handles high dimensional data effectively, robust to missing data and noisy data. So this is the advantage of random forest. Apart for the other like decision tree or SVM, they are bit sensitive to data, missing data, noisy data. But random forest is more robust in this case. So most of the cases nowadays we use random forest. If we use machine learning algorithm, then we go for random forest. That's why. So evaluation matrix for this is area over the receiver operating characteristic curve, AUC, ROC. It's a very popular metric, and F1 score for balance accuracy. So multi-agent system for smart transportation. So again, you can use deep learning algorithms here. So multi-agent deep Q learning systems allow agents like vehicles and traffic signal to collaborate, coordinate vehicle movement in dense urban traffic. Methodology: multiple agents interact with the shared environment. Who are the agents? Vehicles or the traffic signals. Joint reward function to optimize global traffic. So what is the reward function is? To optimize the global traffic flow. Penalize it will be actually bad traffic flow. Policy are learned via decentralized training and centralized evaluation. These are the rules that we have made for to take each place when we take when we move from one state to another state. Advantage: scalability to complex, multi-agent scenarios, and reduce global congestion and improve safety. So we are just in this is the last slide. AI and sustainable transportation. So nowadays you can hear that these are very high up, right? Sustainable transportation, sustainable AI, right? In a very always in the news and everything. So what do you mean by sustainable? So basically, we another keyword for this is greener transportation. So what does it mean by greener transportation? So basically, so we can say it in four heads actually. One is fuel efficiency. So how we can make with minimum fuel, we can actually, because the fuel is whenever we can fuel, the problem is that is just scarce and always in the world, right? Because that's a natural resource and that is extinguishing day by day. So we have to think how to preserve the fuel. So AI model to optimize routes to reduce fuel consumption first. Next is electrical vehicles, because electrical vehicles again that are not using the natural gases. So AI help to manage EV charging networks and predict energy demands. Because if the electric vehicles will increase, where the EV charging point should be there, how the network should be. Because that is nowadays a very crucial problem in India especially. Eco-friendly traffic management, reducing idle time through adapting signal control. So there will be less congestion. Most of the vehicles should always in move. They should not get stuck somewhere. With a adaptive, not a static signaling control, rather than an adaptive control system, we can have an eco-friendly traffic management. Carbon footprint reduction. Obviously, it was there, and for last few years, the government is also working on it. People are also working on it. Predictive logistic reduces unnecessary trips. So sharing cabs, sharing things, all we are working towards so that the carbon footprint should reduce. These are the related publications that I have related to the transportation itself only. These are so you can also get in my homepage. Now it's time for questions, whatever you have, and thank you everyone. So patiently listening to my both the 1.5 hour continuously, 1.5 hour and 1 or 3 hours continuously. So questions for both the sessions.
Ma'am, as I raised the query, like how to decide which model or technique is best suited for test and train a particular data set, ma'am. And may I please have a privilege to request you to please share the slides and video, ma'am, for previous and today's session, this session, ma'am. Is it possible, ma'am?
I think it was not recorded because I cannot see recorded thing because that was handled by IIT BHU meeting host. Okay. Yes, so I don't think it was recorded. And this
slides, ma'am, slides, the previous slides and
हाँ बताइए. Okay.
Ma'am, slides can be shared, ma'am. Previous session slide and this session slide, ma'am.
If it's live, then it's recorded is there. Don't worry.
Okay, ma'am. Video and slides can be provided to the participants, ma'am.
You can request to IIT BHU host.
Okay. Thank you, ma'am.
Haan.
And ma'am, please elaborate a little like how to decide which model.
Okay. So in the last session I said that thing that whenever you have to, let's say you want to start with a machine learning or deep learning algorithm. Okay. First thing you have to look into data. First, you have to look in the data. What is the size of the data? First thing is you have to see what is the size of the data. Because if it is a very small data, then obviously you will go for machine learning and not for deep learning algorithm. If it is a huge data, then you will go for deep learning algorithm. Next is what you want. What is the output you want? Will the output is adaptive or is a static, some classification or regression values? If the output is adaptive, then you have to go for reinforcement learning. If the output is classification regression, then you will go for supervised learning. Now, if you go for supervised learning, you have to see, is the data labeled? If the data is labeled, then you go for supervised learning. If not labeled, then you have to go for clustering. Then you have to go for unsupervised learning, some clustering based method. Now, after that, still you cannot choose what model. Now to see whether data is balanced or not. If it is, if let's say we take it as a supervised learning, you are taking it, it's the data is labeled. Now all the classes data are balanced. So in the last session, I have said data balance and all these things. So with the data balance, if the classes are not balanced, then obviously you have to make the balance. So after getting the raw data, first is pre-process it. When you pre-process it, you will actually remove the noises. But that noise removal does not mean you are actually making the classes balanced. So for that reason, you may have to use some synthetic data production method, like or generative AI method to make the classes balanced. Once the classes are balanced, now you will see if the data is very big, then you will go for a larger deep learning model. Let's say ResNet 50 or ResNet 101. But if it's a smaller data, then you will go for VG 16 or something like that. ResNet 18, you will go for that. So you have to see what amount of data is there. Now, once you now obviously you will not choose only one model. You will choose same type but 3 or 4 models for that. Now, in 3 or 4 models, you will obviously run on that data. Once you've done all this thing, and you do the parameter tuning, and use some linearity also, some regression factors also. Okay, and then you see which one is giving best model. So though there are 100 of models, but you cannot choose 100 of models. You have to choose only 3 or 4 models. But how you will come to arrive to this 3 or 4 models? That is the process till you choose by this way.
Ma'am, suppose we have to find out in all India. Suppose there are 50 universities. Then 5,000 students, data like a subject, then marks, then
see that you have to decide. I will give you example. Like I am in South Korea. Here I am working on transportation. So they have a data of 2 years of the toll plazas, and it is 50 terabyte data.
Yes.
Okay. So all the data, all the sensor data, and including camera data and everything are for 2 years, and then it is more than 50 terabyte. So when I see 50 terabyte, obviously I will not go for any smaller model. I will take a very large model, and not only that,
yes.
I will also see the larger model because even HPC also, high performance computing supercomputers also cannot take the 50 terabyte data at a single time. Then we have to first initial level classification have to done so that it can be divided into chunks. And then in that chunk, either based on the night light, day and night, or it may be time zone, or maybe some criteria have to fit so that I can make it in chunks. And then after I have to train it. So until unless you know the properly, just saying randomly this, that, you cannot decide. You have to actually see the data, how it is, how much noise is there, what is the size of the data. Then you have to work. So here I have come for a collaboration, and here they are working on that. So obviously when we have seen the data, we have said, okay, this is the data, then this type of models can work. But before that, we have to do a lot of pre-processing, lot of synthetic data generation, so that the balancedness in the data set should come.
Okay. Thank you, ma'am. Thank you for your explanation.
Okay. Any other questions for anyone else?
Yes, ma'am. I want to know, ma'am, in the problem like video anomaly detection. In the surveillance video. So what could be the state of our technique currently followed for the unsupervised video anomaly detection? Because it is very difficult to capture all different types of anomaly, like in the videos, like protest, someone is protesting, there is the crowd, or there are a variety of the anomalous events, so it cannot be captured with the class levels. So can you bring some light on what could be the approach for the unsupervised video anomaly detection? Like,
see, see, yes. What I'll say is I'll just show you something. So see, this is the first paper. Can you see it? It is on fault detection. Okay. So it is not like that we cannot. Nowadays, it's in some place, if I say there is no supervised data, it is really not good. Because if you actually search in the literature, you see lot of things. So I can say you at least more than 100 classes of anomaly for human activity detection are already there, and these are labeled data sets that are already available in the literature. First, all the you can name them mostly some of the anomalies. I will say mostly they are exist. So here this paper as well as this paper, all this paper they have used the benchmark data. This is the crowd crush. Okay, crowd crush means stampede, and this is all type of false. They are both of these paper have used the benchmark data sets. So as I said earlier, unsupervised data, you can use unsupervised learning, but the results for the unsupervised learning accuracy are very poor, normally very poor. Okay, so very less people used this unsupervised learning methods. Okay. But if you search properly, I highly likely for most of the cases you will get a data set. If not, then you can go for any autoregressive or some unsupervised learning methods.
Okay, ma'am. Thank you.
But first, always try to find a benchmark data set. Both. Otherwise, if you get an accuracy of 20% or 30%, what will do with that? You will be puzzled. You will completely puzzled. You will understand. You cannot understand whether your selection is wrong or the model is wrong. So always try to find something which is benchmark data set. If you get an abnormality, you will see it later. First train with the what are available. At least 100 or 200 abnormalities you will get easily. Can you please mute your someone has unmuted, so it is very noisy. So at least I will say there are a lot of data sets are already available for that. So please try to search them on. If you don't get, then go for it. There's no one has said not go for unsupervised, but obviously the accuracy is really very less. And there's, as I said, that going for direct unsupervised, then go for one-shot learning or two-shot learning. Label something and the rest you leave. Go for that. Or zero-shot learning, you can go for that model. They are also like 5 years back, they are existing. They are at least better model than pure unsupervised learning. Okay.
Yes, ma'am. Actually, I'm asking unsupervised learning because in many cases we only want to know whether there is an anomalous event has happened or not. We are not more interested in that which type of anomalous event has occurred.
That is binary, right? So, that is binary.
Yes. So that's why I want to know that if we have the only binary type problem, means if we can able to train our model on the normal data only, and if there is any deviation from the normal data, so then the anomalies we can say that there is an anomaly. And so
that you can undo. Like that same thing I said in traffic now. Same thing you can do in activity. In the level 1, you do an unsupervised classification of anomaly and non-anomaly, normal and anomaly. That you can do, always do, so that the number of cases can get reduced and you get a smaller data to explore. That you can always do.
Yes, ma'am. Okay.
Any other questions for anyone? Okay then. Thank you. Thank you everyone for patiently listening to my lecture for 3 hours. And I hope that if you have any questions, that obviously you can ask me anytime. I have shown you my in the first slide my email ID, as well as if you want to extend the works that I have done already, you can always contact me because most of the works have their data sets as well as the codes are available. So if you have interested, you can read them and you can extend them. Thank you. Thank you everyone.
Ma'am, please, ma'am, can you please share the slides to the organizers so that I can request them to share the slides along with.
I will talk to them. I'll talk to them.
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah.
Thank you, ma'am. Thank you for your explanation.
Yeah. Thank you. So, okay. Bye.
Bye, ma'am. Thank you.
Thank you, ma'am.